rocket was Mars Pathfinder.
It rocketed 499 million kilometers, traveling over 19,000 kilometers per hour.
Spacecraft is gone. Roger.
Now the Pathfinder spacecraft lands on Mars.
I'm John Holloman. Join John Zarella and me for complete live reports and witness the first ever television images beamed from the surface of the red planet.
On CNN International.
Spacecraft from Earth will attempt to land on Mars. Once the U.S.-made Pathfinder is on the red planet's surface, it will release an exploration vehicle known as the Sojourner buggy. That is, if all goes as planned. CNN's John Holloman has the details.
For Pathfinder to do its job, the rest of today will have to be virtually flawless. The next big event will be Pathfinder's entry into the atmosphere of Mars. Its heat shield will protect the fragile parts inside from burning to smithereens. At least that's what project manager Donna Shirley hopes for.
When we hit the atmosphere, the heat shield keeps the friction of the air from burning us up. The atmosphere of Mars is about 1% as thick as the atmosphere of Earth, but it's still thick enough to slow us down. The heat shield keeps us from burning up. Then we pop a parachute, which slows us down some more. And then it gets really exciting because we lower the lander, which is kind of shaped like a pyramid, down on a cable underneath the parachute, and we fire some retro rockets on part of the parachute to slow it down to 0, and big airbags pop out all around the lander, and we cut the bridle, and it hits and bounces and rolls and tumbles, and then we deflate the airbags, open the pedals like a flower, and the rover's sitting on one of the pedals.
If the airbags work and Pathfinder survives, the spaceship will send a weak radio signal to Earth, letting scientists here know it made it. And then it will shut down as the sun sets on the landing zone and the solar power cells have no power source until dawn. But when the sun comes up, the big picture show will begin. The Sojourner rover will leave the safety of the landing craft and begin its week-long mission to look at everything it can find on the Martian surface. Scientists expect the landing zone to be filled with different kinds of rocks and geological formations. The hope is Sojourner will show us pictures of things we understand and some things we don't.
I think the pictures that Viking took had a real emotional impact. When you saw the rocks strewn across that rusty red surface, at least that's what it looked like to me, these pictures will be of even higher quality. Some of them will be stereoscopic, and I think that the pictures are likely to have a profound impact.
The answers will start coming by the evening, and scientists say they'll be busy analyzing these pictures for years. John Holloman, CNN Atlanta.
Well, supposed to happen. And in about 10 minutes, Q&A will begin early for a special edition of A Space Odyssey. We plan to speak with NASA's Mars Exploration Program Manager and the shuttle astronauts. Well, Mars Exploration Program Manager and the shuttle astronauts. Well, still in space, Russian officials are giving the crew of the crippled Mir space station more time to prepare for tricky repairs. The work was due to take place next Friday, but that date has been moved back to July 17th or 18th. The delay also gives space officials more time to work out exactly how to fix Mir. CNN's Moscow bureau chief Jill Doherty reports.
At Star City, the cosmonaut training center outside Moscow, two of Russia's most experienced spacemen are simulating underwater the complex repair job their Mir colleagues are practicing for in space. The famous Sergei Krikalev, the first Russian cosmonaut to live aboard a U.S. space shuttle, is leading the exercises. He'll be the chief advisor when the cosmonauts on the Mir space station carry out the repairs for real less than 2 weeks from now. It's complex, difficult work, and because of that, Mission Control is giving the cosmonauts an extra 6 or 7 days to prepare.
It will be necessary to reconnect a number of power supplies. Wearing gloves on the suit, believe me, I've been in space 8 times, makes the work very complex.
The simulation laboratory watches every move.
The most important task is to connect the electricity plugs from the solar panels. They're important for the life support, and there are 9 of them, 8 of them located inside the module, and the 9th on the outside, and they have to locate them.
Back in space, the Mir crew had more problems. The gyro system that keeps the space station's solar panels pointed at the sun failed again. Without that system, the crew has to fire rocket engines periodically, but that burns up fuel. Mission Control said it found the cause of the problem and hoped the crew could repair it soon. Meanwhile, specially crafted repair parts for the disabled Spectre module, including a custom-designed hatch, will be launched toward the Mir this Saturday, expected to dock with it Monday. Jill Doherty, CNN, Moscow.
The sky's the limit, or maybe not. We've floated into outer space, we've walked on the moon, and now we explore Mars. Hello everyone, welcome to Q&A. We've got a very special program for you today. So special, in fact, we're coming to you 15 minutes earlier than usual. It's fair to say this show is out of this world. Indeed, we'll be talking to outer space twice. A little later during the show, we'll go on board the Space Shuttle Columbia to meet the astronauts. You'll be able to ask them directly about life in space. But first, we take you to Mars. The Pathfinder probe scheduled to land on Mars within the next hour or so, and we're pleased to have with us from the Pathfinder headquarters in Pasadena, California, the woman behind the whole project, NASA's Donna Shirley. What kind of picture does she expect the Pathfinder to beam back to Earth? She'll answer that question and more. First, though, a little more about the Pathfinder project.
It'll be a crash landing. NASA planned it that way. After traveling to the mysterious red planet nearly 200 million kilometers away, and entering the upper atmosphere at about 27,000 kilometers per hour, Pathfinder will use a combination of parachutes and airbags to bounce to a halt on the surface of Mars. Back on Earth, UFO enthusiasts are celebrating the 50th anniversary of the so-called flying saucer crash landing at Roswell, New Mexico. The United States government has been accused of a cover-up and is alleged to have retrieved parts of an alien spacecraft and even alien bodies. The subject leaves open the whole question of life forms beyond Earth. Well, our world might be asking, is there life on Mars? But NASA says this mission really set out to answer, what is the planet made of? And that's exactly what the six-wheeled buggy called the Sojourner will spend a week trying to answer. Weighing in at less than 20 kilograms, the little solar-powered robot, about the size of a dog, will trundle along the Martian landscape slowly, cameras rolling to give scientists back on Earth their first mobile view of the surface. Pathfinder is the first Earth craft to land on Mars in 21 years. The last was the Viking craft, and others since have failed, including the Russian craft which crashed into the Pacific Ocean last year. It took Pathfinder 7 months to get to Mars, and its pictures will take 10 minutes to be beamed back to Earth, the longest 10 minutes this world has ever known.
Well, there's a look at how the probe's getting there. Let's talk a little bit more about exactly what it's going to do, and who better to tell us than the woman who steered the whole project. NASA's Donna Shirley is joining us live from Pasadena, California. Donna, welcome to the show.
Thank you.
Let me start by getting a progress report. It's almost crunch time, or let's say it's almost bounce time. We hope it's not a crunch. Any progress so far?
Well, everything's going very well. The maneuver last night that was contemplated did not have to actually be conducted because of the accuracy of the last maneuver. So we're heading right for where we wanted to head for. It's going to be a very interesting area, and the scientists are ecstatic.
When will you get your first indications that the Pathfinder's down, that the buggy's deployed and everything else? What's the delay in getting the information?
Well, actually, there's a number of factors. One is we land at 3 o'clock in the morning, Mars time, so it's quite dark. Also, we're landing in the middle of all of these airbags. So by the time we get the airbags, we stop bouncing and rolling, we get the airbags deflated, and we open the pedals, it's just about dawn. Now, the Earth isn't up in the sky until a little after dawn. So the first thing is, first the cameras on the lander have to automatically find the sun. Then we have to point the high-gain antenna at the Earth so we can send the data back. But first, right before that, we're actually going to send a little bit of data back over the low-gain antenna at about 250 bits per second, which is really slow. And that'll be the "Mom, I made it, I'm safe" phone call. And that happens at about a little after 2 o'clock in the afternoon Pacific time.
All right, well, Donna, we get our questions from all over the world by phone, fax, and across the internet. The first one's an email question from Switzerland. This asks, how important is it to NASA to bring humans to Mars?
Well, it's very important, but we want to do it in a reasonable and safe and cost-effective manner. So So first, we're going to send our robots out to scout the planet, just much like sending the settlers out, the mountain men out to scout the American West before the settlers went out. And once the robots have identified places on the planet that are safe and productive to send people, and once we understand how people are going to be able to work in space from using the space station, and once we have the technology to be able to do it all cost effectively, then we'll send people.
A lot of whens, but let's get our first caller on the line. Italy's on the line. Go ahead, caller.
Hi, this is Salva from Italy. I would like to know how the signal from Mars can go back to Earth. Which device can transmit? We have something on Earth that can receive the signal, or what it is, how it works?
Okay, we have 3 big giant antennas on Earth called part of the Deep Space Network. One of those antennas is in California, one in Spain, and one in Australia. And actually there's a whole bunch of those antennas sitting at each of those locations. When the signal is radioed from Mars, it's really very weak because we operate on just a little bit of power from Mars because it's solar powered and we just don't have much power. So these giant antenna dishes on the Earth receive this signal and amplify it and turn it into bits, turn it back into information, and then that information is shipped here to JPL and processed in computers and turned into pictures and other kind of scientific information.
Well, a lot of people are wondering about that scientific information, Donna, what kind of information it will be. This question from the internet says, do you believe that the Pathfinder probe will discover something revolutionary on Mars after the discovery of live organisms on rock samples?
No, Pathfinder is not looking for life, not looking for life. Pathfinder is proving, we hope, that we can land on Mars very cost effectively for just a fraction of what it cost us to land the last time in 1976. What we do hope to do that's absolutely revolutionary is to find out what Mars is made out of. Because although Viking went to Mars in 1976 to look for life, it didn't find any, and it didn't have experiments on board that would tell us what the geology of Mars is. So we want to understand what happened in the history of Mars, and once we understand that, then we'll know better how to go look for signs of ancient life on Mars. But that will take a while.
A lot of viewers will be asking, why Mars? Why is the Earth exploring Mars as opposed to any other planet?
Well, because Mars is the closest place in the solar system, the nearest kind of place that we might be able to go and live as people. So it's kind of our first frontier. Venus is like the Earth, but it's much too hot. You can melt lead on the surface of Venus, and the atmosphere is full of sulfuric acid. You wouldn't even want to visit it, much less live there. Mars, while it's cold and has a very, very thin atmosphere, at least is conducive to being able for humans to go there if they're in spacesuits and actually move around on the surface. But first, we need to understand Mars. We need to find out whether there's water and resources that we can sort of live off the land. And also, Mars is a planet that's going to tell us a lot about what might happen to Earth, because Venus got way too hot and Mars got way too cold and the Earth stayed just right. And we'd like to know why that happened. So exploring Mars will help us understand what might happen to the Earth in the future.
Another question from the internet, this one from Slovenia. It's a question I'm sure you've thought a lot about. It says, what will happen if the Pathfinder lands miles away from the planned landing site?
Well, we know, based on our tracking of the spacecraft, that it will land somewhere within an ellipse that's about 100 kilometers long and about 20 kilometers wide. And it's most likely to land kind of in the middle of that ellipse. But the whole ellipse is right in the area that we always planned to land in, which was about 100 by 200 kilometers. So anywhere we land within that ellipse will be very, very good.
Donna Shirley, don't go away. We have to take a break. Well, for more on the Pathfinder project, check out our webpage on the internet. You can access it at cnn.com/Mars. It's time for us to take a short break. We'll have more with Donna Shirley in a moment. Plus, we'll go on board the Space Shuttle Columbia to find out what the astronauts are up to today. Stay with us. We've Before we get back to today's show, a look ahead to Monday, a day that a key NATO summit begins in Madrid, Spain. Well, topping the agenda is NATO expansion. Member nations look set to welcome new Eastern European countries into the fold. Well, how much will NATO grow, and how is the European Union reacting? You'll be able to ask our guests your own questions. Why not start sending them now by email? The email address is cnni@turner.com, and the fax number, if you use that, is 14048274056. That's on Monday. But now back to today's show and a space odyssey in store for you here. We're talking with NASA's Donna Shirley, a woman who designed the little robot that'll hopefully soon be making its way across the surface of Mars, and with some luck we'll be beaming back some amazing photographs of the red planet. Let's get back to some Q&A. Chris in Israel, you've been waiting. Thanks very much for your patience. Go ahead with your question.
Hello, I'd like to ask Donna, what is the main purpose of landing on Mars? And is there any natural resources that astronauts are looking for?
Well, the main purpose of landing on Mars is to find out what Mars is made out of, number one, which we're going to be able to do with the alpha proton X-ray spectrometer on the rover. The second reason is to prove we can do it for a fraction of the cost it took us to do it the last time, which was Viking in 1976. The resources we're mainly interested in are water, because if we have water, then we can drink it and use it and make fuel out of it. And the astronauts won't have to carry their own fuel when they go to Mars sometime in the future. They'll be able to make fuel on the surface and live off the land to that extent.
Now, Donna, the little buggy, the robotic buggy Sojourner, is due to run for about a week or so, is it? Are you going to just let it die out then, or will you just carry on as long as you can?
Well, the Sojourner rover is, its prime mission is a week, because we just wanted to plan for the mission around that. By the way, I do have a model of the rover here if you want to
Yes, please, let's have a look.
Okay, this is a 5th scale model, and here is the rover, and it will, its job is to go around and investigate rocks. And so it will drive around the surface with it's directed from Earth, but it has its own onboard intelligence, and when it gets to a rock, it'll turn around and put this spectrometer that's on the back of the rover up against the rock. Now, this is a model of the airbags. It's not a rock, but I'm pretending that it's a rock. So the rover will back up to the rock. The rover has a camera on the back that can actually take a picture up close of the rock. The spectrometer gets put up against the rock and measures the chemical composition. And so that's one of its main jobs. Now, we expect that within a week, we'll be able to get to 1 or maybe 2 rocks. But the rover is solar powered. Up here on the top is a solar panel that generates about 8 watts average of electricity, which is about like a night light. And that's enough power for us to do all of our operations during the daytime. There's no particular reason why Sojourner can't live longer than that. And if she does, then we'll just go and find another rock, and then we'll go and find another rock. And at the same time, we're learning about how small rovers can actually work on the surface of Mars by doing things like taking pictures of the wheel tracks.
Donna, that little buggy is so cute. Kids around the world are going to be nagging their parents for one of those. Let's get our next caller on the line. United Arab Emirates is on the line. Caller in Dubai, your question, please.
Hi, my name's Anand, and I'm calling from Dubai. My question, before I actually give my question, is first of all, Donna, I'd love to congratulate you on the incredible Pathfinder mission that you've done, and all my best wishes. In fact, I think I'm wishing this best of luck from, in fact, all over the world.
Yeah, we have to squeeze in the question quickly.
I'm very, very optimistic that well, my question is, what happens after the Pathfinder mission? What I mean to say is, Pathfinder does its job, it finds all the information and everything. Will it speed up the actual landing of man on Mars? Because you say...
Okay, let Donna answer that, because we're almost out of time. Go ahead, Donna.
Okay, yes, Pathfinder's job is to prove out some of the technologies and find out about Mars so that in the future we can design human missions to Mars. But there'll be several more robotic missions sent before humans are sent.
Donna Shirley, I'm afraid we've run out of time. We have so many more questions for you. We had so many email questions sent in as well, and viewers on the phones we couldn't get to. Our apologies to all of you. But we thank you very much for joining us from Pasadena, California for that.
Okay.
And our thanks to John Holloman, of course, and the crew of the Space Shuttle Columbia. First for Q&A, questions going out of space from around the world. And not to forget our thanks for you sending those questions in. We're back on Monday again at our regular time. I hope you'll tune in for that, for the NATO Summit Show. Right now, stay with CNN. There's much more ahead.
CNN International. This is World News.
Good afternoon from the CNN Center in Atlanta. I'm Jonathan Mann.
And good evening from London. I'm Hillary Bowker. Coming up on this edition of World News, making contact. Just minutes from now, the Mars Pathfinder will attempt to land on the red planet.
And practicing contact. Russia's cosmonauts simulate repair work for the crippled Mir space station. Thanks for joining us. This is one of those moments scientists have been waiting for. Like nervous parents, they've been watching the Mars Pathfinder move through millions of kilometers of space headed to the red planet. And right now, the spacecraft should be approaching its final descent. Joining us to explain what to expect is Kurt Grimaud, a professor of aerospace engineering at the University of Oklahoma. Professor, thanks so much for being with us. You and your team have prepared some sophisticated animations. Talk us through these last few minutes as Pathfinder makes its way to Mars.
Thank you. It's a pleasure being here. The spacecraft is only 7 to 8 minutes from landing on the surface. The animations were done in order to help NASA and JPL instruct the people around the world about what is actually happening. It's impossible to put a camera up there in space and be able to show it real time, and so the next best thing is to have photorealistic animation done.
Okay, so now this package coming from Earth is whizzing towards Mars. I think we can see it there. What are we watching?
Yes, this is just before the tether gets cut and the rockets on the back shell gets fired to get it out of the way. You'll see those fire there. That's simply to get the parachute out of the way as the airbags have been inflated, moving down to the surface, and it's bouncing along the surface, trying to come to a rest.
How high is it bouncing right now?
It can range anywhere from 3 or 4 stories high, maybe up to 6 or 7 stories high. The gravity on Mars is only 1/3 that of Earth. The most important reason why it bounces a lot is that those airbags are like super balls, that they're made out of a very stiff material that is highly inflated, and it'll bounce very high.
What is going to happen now? The thing will come to rest and take us through what they're hoping will happen.
After 5 to 10 minutes, it'll finally come to a rest. It'll take over an hour to deflate and to retract the airbags. As that has been come to a stop, there it shows the airbags deflated. After they're deflated and pulled back in, then it tries to open itself up. And it doesn't matter what side or what pedal it lands on, it'll always ride itself back up. The reason the airbags had to be pulled in is so that when the rover moves off one of the pedals, it will not get tangled up in the airbag.
So is this a sure thing? It looks like they've thought it pretty well through. Are they very confident that this is going to work and everything's going to make this enormous journey without any problems?
They are as confident as you can ever be with a space program. There's always something that could possibly go wrong. They've done extensively testing, both on Earth and especially test chambers for bouncing of the airbags and opening up the pedals and having the rover move off.
Now, while we're talking, we're watching this move ahead. We're looking at the rover. Is this going to happen as quickly as all of this? Is this expected, the rover, to start moving within just the next few minutes?
The rover is the very last thing that will happen on the initial day if everything else goes correct. So it'll take over 12 hours before the rover actually will leave the pedal, if it's in a condition to do so.
Right now, the Pathfinder is still on its way. We have seen it land. It looked like it was coming down rather gently, but it's going very fast now, isn't it?
Yes, it is. It's going 7.5 kilometers per second. You can travel a lot of distance in 1 second, 7 kilometers. When it comes through the atmosphere, it'll slow down to 500 meters per second. The parachutes will open, and after that, it'll slow down to maybe 40 or 50 meters per second. When it impacts the surface, it'll be going at about 30 to 40 meters per second, and that's one reason why it bounces so much. It is moving the speed of a car when it hits the surface.
We're going to go now to the Jet Propulsion Laboratory in Pasadena, California, and listen in because they're hard at work there and awaiting news of the landing as well. Let's listen in. I'm curious about something. While they're working and waiting, they're now just 3 minutes away from there.
In about 15 seconds, the events will follow will occur in rapid succession under the control of the onboard software. I'll report these events as they are expected to occur.
If you're just joining us, we're now approximately 2 minutes and 20 seconds from the landing that's been scheduled.
As this landing takes place, it's very difficult to get this information back as it's going through the atmosphere. Some of the radio waves may not be in full power and be able to get receptions, but it seems at this point that they are getting information back as it's going through.
It's easy to take all of this for granted. We're so used to seeing pictures from the space shuttle. We're so used to seeing pictures from the space shuttle, but really they have very little information.
Slowing down rapidly because of parachute deployment. The heat shield should separate in about 3, 2, 1, 0 seconds.
After the heat shield separates, the parachute is slowing it down. The airbags.
The next event is lander separation. That should occur in about 5 seconds. When that occurs, the lander will descend in about 10 seconds down the bridle. Lander separation should have occurred right about now.
You'll notice they say should a lot. Many of these information is pre-programmed and they're not exactly sure when it's actually
We should
happening.
be switching from one antenna to another antenna under a flight software control. This is an antenna that proves our ability to see the signal during this descent phase.
So is any human being now in control of this?
No, it is not.
Is any earthbound computer now telling you what?
No, the best we can do is get information back from the spacecraft, and that in itself is difficult.
This is an autonomous entity that's acting on its own intelligence and all of the machinery they could put inside, but it's far beyond anyone's ability to help or control.
I'm not sure if I'd say intelligence, but it's programmed. It's a computer that has a sequence of events that it's following.
While we're waiting, and while they're waiting, I've got a question for you.
The spacecraft should be approximately a mile above the surface of Mars. There's a lot of uncertainty in the timing from here on out because of the variation in the atmosphere.
The atmosphere, this is my question. Mars, if I've read correctly, has an atmosphere only 1% as dense as Earth's. How does a parachute work when there's air or something to slow the craft down?
Very good question. It
Airbag
does not
should be
work hardly at all, but it does add some slowing, so they use it. If they would work like a parachute on Earth, they would not need the airbags to bounce along. They could just do a gentle drop.
Okay, let's listen in now. I'm just struck by what we're seeing now. This is a moment that they've been working for years, but it comes down to a bunch of guys, ladies and gentlemen, walking around with their arms folded and their hands in their pockets, waiting for news like expectant fathers, really.
It's a very good analogy, is you have to receive information, you cannot help it in any way. What's going to happen is going to happen, and all you're doing is finding out if it was successful or not.
Correct me if I'm wrong, I am told
that a signal is barely visible.
They are getting a signal back. That is great.
It's a very good sign, everybody.
The signal has been received. It means that the spacecraft is intact. At least it has enough information to be able to send a signal out. It does not mean that everything is operational. That will only tell over the next 12 hours as they start testing each piece of equipment, getting the big antennas out to be able to broadcast pictures.
But what you're seeing now is, as close as we can show you, visual evidence that Pathfinder has landed in one piece with at least enough of its technology intact to phone home and tell everyone that it is okay.
Yes. Now the real fun begins, where you start doing engineering experiments, science experiments, to find more information about Mars, the planet itself.
Now, there was enormous confidence going into this mission that this was going to work. In the last few days, we saw some very confident scientists saying that they really were feeling very positive. But in terms of engineering and science and the hard work that these people do, how hard has it been to get something successfully landed on Mars?
It's probably as difficult as any mission has been. The nice thing about this one is that it's a smaller one, it's compact. These people are much closer together. It is like a small company coming out with a new wonderful program. They've all worked very hard. It's a lot of energetic people trying to pull this thing off against a lot of odds. and you get very nice products and success when you have that kind of a group working together.
As it would expect it to do after it rolls to a stop.
What?
We are now in a blackout situation where the spacecraft will essentially begin to retract airbags. This process takes a little over an hour. Hopefully, we may see a signal when that finishes up. We will keep our eyes peeled, of course. Seeing a signal from the surface of Mars is actually the hard part.
The signal is extremely weak, and for them to be able to receive a signal is a difficult and wonderful thing to have.
What was the signal that made them so excited? Was it a little beeping noise? Was it a computer entry? Physically or technologically, exactly what did they get?
It's almost like the static you would have on the FM radio, and the level of the static will tell them some information. That is about all that they're getting. The static is enough different than the normal static that they can identify that it was a signal made from Mars.
It's an extraordinary thing. Something created on this world has now gone to another world. Let me ask you, we can't get a sense of it watching these gentlemen in their air-conditioned quarters, but what kind of conditions have greeted Pathfinder? Is it cold? Is it hot? Is it dark? Is it bright? Is it sunny? Do we know what the weather is like there?
They landed in the night side. It will dawn in about 3 more hours. At nighttime, it can get as cold as 100 degrees centigrade below zero. The warmest it'll get is about 40 degrees above 0 centigrade. So it's very cold. They have to have special warmers in the rover and in the lander to make sure that the electronics continue working and that the battery power will be conserved.
One of the extraordinary things looking at this is that these experts are really as close as anyone has ever come to Mars. They're doing this extraordinary project. Oh, let's listen to what they're saying. These are the greatest living experts on Mars, one would imagine. How much does anyone really know about that planet?
The duration of this signal should tell us a little bit about what the software thinks the spacecraft is, how the spacecraft is oriented.
20 years ago was the last time we had significant information come from Mars. So it's over 20 years since we have any new information other than what the Hubble telescope has been able to give us. So we only know maybe 2 or 3% of what Mars may have to offer to us over the next 20, 30 years as we send 10 more missions to Mars.
For those who are interested, the spacecraft successfully fired off 41 pyrotechnic devices that all had to work perfectly on the 4th of July.
Telecom reports solid state power amp off.
Those pyrotechnic devices blow bolts so that the airbags can be retracted inward. You can't get up there with a wrench and unscrew things. You have to have small explosions to unlock bolts and to get things to start working.
They noted with glee that this is, of course, the 4th of July.
Communications folks to calculate how long that signal was active, maybe give us an idea how long what orientation the spacecraft is in. The signals that are possible are either you're on the base pedal, which means that the spacecraft does not have to roll over, or it's on a side, in which case it will right itself automatically.
We have a model. You have kindly brought a model of the landing craft. I don't know if we can get a tighter picture of it, but if we can, why don't we put it, there we go. We're moving in and out of the shot. There we go. Show us what it is that is going to happen. There was some talk about the pedals and about whether they would be able to...
This is the heat shield that went through the atmosphere and was discarded. This here is what landed on Mars. It does not have the airbags around. Currently, it's sitting on Mars in some configuration with large airbags on the side. Those are now being deflated, and they'll be pulled into the surface. After about 3 hours, these leaves or petals will open up,
an ingenious thing about them, I'm going to interrupt you. They didn't know which side it was going to land on, and that's part of the design here. Show us.
That's correct. The way this thing was designed is that it could land on any one of the petals, and it will correct itself with these motors that open up the leaves. They're strong enough that they can turn the whole lander around, and then the other two leaves will open up. There's only one concern that they may have, and I'm sure many of the people watching may also ask, what happens if it lands on its top? How does it open up? This is like trying to balance a pencil on your finger, and it's more than likely going to tip over. If it does not, they can jiggle these leaves to try to jar it off to one side and fall over.
So one of the things they're waiting to find out right now, I guess, is how it's landed on which side.
That's correct.
There was also some talk about the craft itself orienting itself. How does it do that in a strange world? It doesn't know where it's facing. It doesn't know how it's landed. How does it figure out and tell the experts back home where it is?
The best way to orient yourself in space is to be able to know where the sun is. After the airbags have been retracted, the pedals have been opened, this camera device here will start moving around and look for the sun. As soon as it locates the sun, then it knows exactly where it's at, what angle it's at, where the Earth is at, and it can send up their high-gain antenna here to be able to get high-speed transmission back to Earth, and that's when the pictures will actually start being sent.
This relates back to some of the delay that we've been hearing about because, once again, as you've mentioned, it's night on Mars right now.
Yes. When these pedals are open, it'll be around dawn. That's when they'll have the low-gain antenna try to communicate to Earth. After that, then they will use the camera to locate the sun, tell them where to point the high-gain antenna. After they get the high-gain antenna working, they can transmit back nice pictures to look around to see what the environment is like. If that's successful, then they will contemplate sending off the rover off the pedal and move just a few meters away from the lander, and that would be a very successful first day if they can get that lander off, or the rover off the pedal.
For the time being, enormous technology, enormous effort that now rests on Mars in a bundle of balloons, and they're waiting for the sun to come up. Professor Grimal of University of Oklahoma, thanks for being with us. Stay with us. We're going to have to take a break, but we'll be back in a moment.
Spacecraft has landed base pedal down. What are the odds? No speculation.
With the landed on Mars on time, everything appears to be working well. And of course, as we get any news on what's going on, we'll bring it to you here on CNN. Well, in another part of the galaxy, things are running a little bit behind schedule. Russian space officials say they're delaying repairs to their Mir space station for an extra week until at least July 17th. They want to give the Mir crew extra time to practice repairing a damaged module known as Spectre.
NASA scientists have reason to cheer. The Mars Pathfinder has landed on the red planet. The entry, descent, and landing about half an hour ago went exactly according to plan. The U.S. spacecraft parachuted through the red planet's atmosphere and landed on an airbag cushion. NASA received signals from the spacecraft as it entered Mars's atmosphere and as it landed, but is not to receive any more communications from the Pathfinder for a few hours. The spacecraft is to release what's known as the Sojourner rover, that vehicle designed to creep along the terrain and send pictures and data back to Earth. Scientists have been nervously waiting this event, but one of the scientists who's been careful enough and kind enough to join us to talk about it is Kurt Grimal of the University of Oklahoma. Thanks for staying around to talk to us about it.
Thank you.
If you were watching before, we broke away to go to commercial and then went to a live picture from the Jet Propulsion Laboratory where scientists cheered for a new reason. They were told that the Pathfinder had landed on the base pedal. What is it that made them so happy about that?
Here is a model of the lander as it's currently resting on the surface of Mars. The only thing missing is the large airbags that have deflated and they're going to be pulled into the pedals. There is 4 different sides to this. This is called the base because if it opens up on the base, the other pedals will go off to the sides, and the base has the main equipment at the center.
So if they're rolling the dice, and this is a 4-sided dice, they got the best possible roll, I guess.
Yes. Another option would be on one of the pedals, in which then it would have to correct itself, which is a little more tricky to do. They certainly designed it for that, but by having it land on its base at the first time, it solves a lot of other problems.
Now, we're looking at this little model. It's a cute little thing. Give us a sense of the real scale of this. How big is the total package and the crucial rover on which so much rests? How big are they?
Well, to compare it to my hand here, this is a 1/10 model, so it would not be much bigger than the size of this table when it fully opens up. This rover itself is no bigger than a microwave oven. It's approximately a half a meter long and 1/3 meter wide and only maybe 20 centimeters high.
So this has been traveling through hundreds of thousands of kilometers of space, essentially to get something the size of a child's wagon to Mars, or
yes.
smaller.
But that's the nice, exciting thing about this, is every child in the world can relate to their own little remote-controlled toy that many of us have played with in our younger years. This is about the same size. And just like we would play with a remote-controlled toy, the NASA engineers now get to play with their $25 million remote-controlled toy.
Well, I want to ask you more about that. Are they literally, is there one lucky kid at NASA sitting with a joystick that's going to be telling us where to go?
There's 3 or 4 that will be operating the rover, but it's not quite like when we were young and we would push it forward and immediately would go forward. There is a 10-minute time delay, so that if we say go forward, in 10 minutes it'll go forward. If there's a cliff and we say stop, 10 minutes, it'll stop, hopefully not going over the cliff. Because of those problems, they have to have a lot of the intelligence built right into the rover. So it'll point to a direction and say, we want to go look at that rock. The rover has enough computer power and enough decision-making ability to be able to know the right path to get to that rock.
Now, as we're looking at this model, I don't know if well, we can see the picture. Those beautiful blue things. That's not just a colorful covering, is it? That's actually going to be an important part of the operation. The blue surfaces that we're seeing.
That's a solar panel, and one of the critical things about this mission is the power. They don't have enough, and they try to get as much power as they possibly can. So the whole top surface is a solar panel. That solar panel will help operate equipment on the rover. It'll also charge the batteries that are on the rover. Without that, they will not be able to have an extended mission. There is enough power in the batteries to go 7 days, but if they want to go beyond the 7 days, they're going to have to draw heavily upon these solar panels to recharge the batteries and to keep it going.
Right now, though, once again, it is a cold night on Mars that has welcomed the rover and the Pathfinder. Dr. Kurt Grimal, I hope you'll be with us some more in the hours to come. I am told you will, to explain all of this mission as it proceeds. For now, we thank you very much for your expertise.
Thank you.
Hillary?
Well, John, you know your kids are going to want a copy of this little rover, and it's not just a $25 million toy. It is, of course, the focus of Pathfinder's mission, and it is supposed to collect and chart data from the planet's surface. Well, it will be done from the Sojourner buggy, as we just said, and CNN's John Zarella is going to report on how that vehicle came about.
There have been big ones. There have been little ones. For years now, rovers of all sizes and shapes have run over rocks, cruised along desert landscapes. They've been tested and redesigned over and over again. Finally, this. Sojourner is what engineers and scientists chose to send to Mars. This is where much of its testing took place, the sandbox at NASA's Jet Propulsion Laboratory in California. Sojourner, a 6-wheeled, 23-pound solar-powered rover, is the centerpiece of NASA's Pathfinder mission.
This will be one of the first images we'll get down from Mars. This is obviously of our test bed, but what we want to look at is make sure that these airbags are underneath where the ramp would deploy here.
If the lander and Sojourner survive the airbag landing on Mars, Sojourner will begin its snail's pace crawl across the surface. Once it finds a rock scientists back on Earth find interesting, the rover's alpha proton X-ray spectrometer will spend up to 10 hours analyzing the composition.
The rover stops the last thing in the day, puts the spectrometer on the rock or on the ground, and it just collects data all night long, and then by the time the sun comes up the next morning, the rover's ready to go off and move again.
With the ability to analyze 1 rock a day, engineers and geologists hope the little vehicle just keeps on going and going. This is the Mars Yard. Scientists and engineers here have already forgotten about Pathfinder and are working on the next generation of Mars rovers. This is Rocky 7, the latest in mini rovers. It looks like Sojourner, but is far more autonomous.
As a rover in the future moves away from the lander, it needs to be able to look at the terrain all by itself and tell itself where to go.
Rocky 7, or something similar, will fly to Mars in 2001. It will gather rocks and wait there until 2005. That's when NASA plans to send a vehicle to pick up the samples and bring them back to Earth. John Zarella, CNN, Pasadena, California.
Fascinating. Well, the surface of Mars may be a subject of intense scrutiny to scientists, but to show business, well, it's well-charted territory. CNN's Dennis Michael looks at the view of Mars from Hollywood.
Years, we should soon be getting a ground's-eye view of Mars. After a 7-month journey, the Mars Pathfinder has landed on the surface of the red planet just a little over an hour ago. Padded by a cushion of airbags, the Pathfinder bounced to a halt and signaled NASA controllers all was well. The news prompted cheers from the scientists at NASA's Jet Propulsion Laboratory in California. They grew louder and more excited as it became clear Pathfinder has landed in the optimum position. NASA should start receiving the first pictures from Mars in about 2.5 hours. And joining us from Atlanta to help us with the Pathfinder story is Kurt Grammel, aerospace engineering professor at the University of Oklahoma. He and his multimedia company helped develop the animation we've been using in our coverage of this event. Well, Dr. Grammel, give us a sense of what an achievement it is. It has landed and in the right position.
It's a wonderful day. You need to remember it's been 21 years since we've had any lander on Mars, and furthermore, the 3 or 4 missions that have been sent up over the last 20 years have failed. And so it's been a kind of a jinx or a girl that has been out in space grabbing these spacecrafts. So finally have one landed is just fabulous.
What do we actually know in terms of the condition of the Pathfinder, how it is and where it is?
All we know is it's not in a million pieces. It is in one piece. It's sending back a carrier wave, which is a signal, letting them know that it's alive and it's starting to do its operation of pulling back the airbags, and then it'll open up the pedals. And it won't be for another 2 to 3 hours before we can communicate with it and send it information requesting engineering data to be sent back.
Once that opens, what happens then?
Well, I have a model here that I'd like to illustrate what will happen over the next day. Here is the lander, and it originally landed correctly straight up, which was wonderful. The pedals will open after 2 hours. After it becomes open, then the low-gain antenna will send a signal out trying to locate the Earth, communicate with Earth. Earth will come back and tell it that it's where it's at. At that point, it'll take a camera picture of the horizon trying to find where the sun is. Finding the sun is important. It'll give the location of the spacecraft so that it can point its high-gain antenna. The high-gain antenna will allow it to communicate much quicker and faster. After the high-gain antenna is pointed directly back to the Earth, the camera will once again be activated and be able to take black and white pictures and then later color pictures. If that all goes well, then they'll make a decision whether to send the rover out off the pedal into a nearby area to start analyzing the soil. But that'll be the last thing that will be accomplished today if everything else goes well.
The question is, this was above all a test of technology. What have we learned so far?
Well, the airbag technology works. That the lander did not break into a number of pieces, that it's landed on Mars. The next part of technology that will be tested is actually the rover, to be able to get it off the panel and be able to move around and analyze soil. Those are the two big engineering feats that they're trying to prove on this particular landing.
Now, that rover partly moves around with its own artificial intelligence and partly it's told what to do by remote from the scientists in Pasadena, California.
Yes, it's a nice mixture of both. The reason why they cannot totally control it is because there's a 10-minute time lag. If it was heading towards a cliff and they were being remotely controlled and you said stop, it'd take 10 minutes before it stopped and it could go over that cliff. So they have to have some type of artificial intelligence in the computer so they can make decisions on its own without being told. It'll be told where to go to, but it'll have to figure out how to get there.
How does it figure out how to get there?
There's been a lot of computer scientists programming its intelligence. It has a very powerful computer on board. In the front, there are 5 lasers that'll detect different sizes of rocks. where they're going to, what they are, how big they are, if they should go over them, or whether they should go around them.
Now, the part of Mars where the Pathfinder is, and hopefully the rover will travel around, was very carefully chosen. What's special about this? Why have they chosen this area?
For one reason is they would like to know more about the landscape of where they thought large amounts of water have rushed across the surface or formed rivers. The area here is a riverbed and a delta area. The other reason why the delta area is nice is that it's flat and will have very few craters and large rocks. If it had a lot of deep crevices and rocks and canyons, it could damage the lander when it was bouncing along. Furthermore, it could get stuck and not be able to have the rover go out. So they wanted an exciting site, but yet one that was relatively flat and rock-free.
Thanks to Kurt Grammel, aerospace engineering professor at the University of Oklahoma. Pictures should be arriving within the next 2.5 hours from Mars. Our guest will also be appearing on Insight Special, Exploring the Red Planet. How do we do it? That'll be Insight on CNN, also about 2 hours from now. The crew of NASA scientists have been waiting for us finally arrived. About 2 hours ago, the Pathfinder space probe landed on the planet Mars, beginning an extraordinary mission that will carry it across the red planet's surface. But some nail-biting moments remain ahead. CNN's John Holloman joins us from the CNN Center in Atlanta to tell us more about this exciting day in space. John.
Sonia, it is a lot better than we thought it was, even the last time that you and I spoke. We thought the first pictures would be coming up about 4 hours from now. Now it turns out they're going to be coming up 2 hours from now. They've managed to do something. This little robot on the surface of Mars has managed to have more electricity in its batteries than people thought. The sun is coming up on Mars on schedule. Looks like we'll get our first pictures in 2 hours instead of 4. And this was the reaction at NASA's Mission Control at the Jet Propulsion Laboratory when they got an update on how well the Pathfinder mission was going on the surface of Mars. Listen.
We've confirmed that the spacecraft has now completed pedal deployment, and we're transmitting our final semaphore on the low-gain antenna. We now expect to get a signal in the spacecraft at 2:09 Pacific Daylight Time with real digital data. Stay tuned for more excitement from Mars Pathfinder.
These guys are engineers. They're highly technical people in that room, and the fact that they are jumping up and down, hugging each other, is a sign that they are acting very unusually. But so is the Mars Pathfinder on the surface of Mars. Joining us to show us what it looks like, show us what is happening on the surface of Mars, Professor Kurt Grammel, now of the University of Oklahoma, but just a few days ago you were at Georgia Institute of Technology, where you came up with a lot of these beautiful animations that we and the folks at the Jet Propulsion Lab have been using to try to explain to ourselves and to people watching how this thing was going to look as it made its way through the Martian atmosphere. Kurt, you heard that announcement from the Jet Propulsion Lab. I hope you did. The word was, first pictures a lot sooner than we thought. How could that be?
This is just an exciting time. Everything's going picture perfect. And the reason why they've been able to get it out sooner is that these pedals on this model that I have in front of me was able to open up quicker, and thus they're able to communicate back to Earth with this low-gain antenna. And that's what they were so happy about this last round, is that they can now talk back and forth to the landing craft.
And that means they can tell it, okay, go ahead and start taking your pictures sooner than they thought they were going to be able to.
The next big task is to take some very simple readings of where the sun is with the camera. And they won't be photographic pictures, but it'll tell them where the sun is so that they can point the high-gain antenna back to Earth.
So if the thing can see the sun, it knows where the Earth is and can aim the, the big dish rather than the little radio antenna back to Earth and set up a lot of good pictures, I guess.
Without the high-gain antenna, it would take a very long time to send any information such as pictures back to Earth. So they want to make sure they get this high-gain antenna directed back to Earth so that they can get those pictures back to us within 2 hours.
You got a globe of Mars there, Kurt, and this may be a question that you don't have the answer to. I have a much smaller globe of Mars with the landing zone on it. Do you know where on the surface the Pathfinder is on the ground, give or take a few 100,000 miles?
Oh, of course. One of the easiest things to recognize on a globe is there's a large trench area, and it's larger than the Grand Canyon by about 10 times. You locate that and everything else becomes relative to it. The landing is actually up into this area, and it's kind of a river delta, Arius Vallis, and the Viking landing was only a couple hundred miles away, so it's fairly close to that, and that's one reason they chose that site, is they're a little familiar with this area.
So if they had gone someplace totally different from the Viking landing spot, they might have found, they would have known what?
Well, they could have hit a very large mountain or canyons, and it might not have survived the landing. So they were very worried to get a fairly flat surface so that the landing would be successful.
Yeah. What do you expect to show up in the first picture that we'll see now in 2 hours and 5 minutes from now?
It'll be a panorama shot of 5 or 6 pictures towards the direction of the rover, wherever the rover is going to be going off. They want to get some pictures in that area, because once they get the pictures back, the next decision they have to do is, are we going to send that rover off the pedal? And that's what these pictures are for, not for us to look at, it's for to guide whether that rover is going to be able to leave the pedal or not.
Okay, well, let's move our model around toward the camera. So the pictures are going to be looking this way, basically,
yes.
out here, because this is where the rover is. And the rover has got a couple of little roll-up sort of red carpet tracks that it uses, right? They'll roll out so that it can get, in case this thing was up on a hill, it could go down the side of the hill without turning over, basically.
It's not shown here, but there's 2 ramps that will go out about 3 or 4 meters so that it can make sure it can come off this sharp edge. And also, if the airbags were not totally retracted, it'll go over the top of those. They're very concerned that those airbags have gotten retracted. If it gets tangled up in those airbags, the rover will get stuck.
And that first picture will tell them that as well.
Yes.
All right. So this is the Pathfinder's eye view. It will be looking down here at the rover, make sure it's okay, and further out here in front to just see what's out there for them to explore with the rover.
There will be 2 passes of pictures. The first is a fairly narrow angle. Then there'll be a second pass of pictures that'll give a wider view. And then the decision will be made whether to let the rover go off the first day.
All right. And so if everything else is 2 hours ahead of schedule, does that mean the rover might be leaving 2 hours early?
Very much so.
Wow. So for the scientists, that means I may not have to be here until 2 o'clock in the morning Eastern time. We might have our first pictures before that. It's fascinating. Let's talk about the planning of this mission. I mean, you are sitting here and you know all this stuff. You know that the first pass of pictures is going to be this wide and the second pass will be that wide. This has been extremely meticulously planned, hasn't it?
For 4 years, they've laid down the groundwork, and I was given a mission plan 3 years ago. The reason I was looking at the mission plan is to prepare for the animations. I've also put together an educational CD-ROM for high school and junior high students. I was able to take the information in that mission plan and put it together as an animation.
All right, so school children in the United States and perhaps around the world could get access to your CD-ROM and learn a lot more about this, because that's what we've been using on TV. It's just fabulous video. All right, listen, Kurt, thank you very much. You're going to be here a lot. You're going to consult with us throughout the rest of the mission today, and we appreciate it at CNN International. So, isn't this good? We've got great guests all over the place to help us understand this.
John Holloman and Professor Gromwell from Atlanta, thank you both. And just another reminder, those first pictures from Mars, black and white pictures, will be arriving back to Earth almost exactly 2 hours from now, and we will bring those to you live as NASA gets them, so stay with us. But while Pathfinder is checking out Mars, U.S. astronauts aboard the shuttle Columbia are conducting experiments that may one day aid manned flights to the Red Planet. Specifically, the astronauts are constructing a mini greenhouse that will allow them to see how various plants grow in space. Future travelers, for example, to Mars, would likely need to grow their own food. The astronauts are also conducting tests with fire. They want to see how flames spread in weightlessness. The shuttle astronauts also had words of encouragement for their colleague, Michael Foale. He and 2 Russian cosmonauts are preparing to make complex repairs to the crippled space station Mir. And as CNN's Moscow Bureau Chief Jill Doherty reports, those repairs are going to be tricky.
Pathfinder has landed. The unmanned spacecraft touched down on Mars about 3 hours ago after a 7-month journey. Now anticipation is building for the first transmission of pictures and the start of the 6-wheeled rover's exploration. CNN's John Harleman, our space expert, joins us now from CNN Center in Atlanta to tell us more. John?
Hillary, this is one of those stories that really plays well on the CNN International Network, and if we had viewers on Mars, they'd be interested in watching it as well. And maybe we do. How do we know for sure? At any rate, the Pathfinder has plopped itself down on the surface of Mars. Those huge airbags have deflated. Right now on NASA television, there is a picture in a sandbox at the Jet Propulsion Laboratory that shows precisely what we would be looking at if we had a camera somewhere on the surface of Mars looking back at the Pathfinder. That's what it looks like. The airbags have all deflated. The three triangular things on the three corners of this are solar panels that are just beginning to pick up the first light of the Martian sunrise at the landing zone on the Martian surface. And what we anticipate will happen, if you look at that live picture from the Jet Propulsion Lab, it's not of Mars, it is of an identical Martian rover to the one that is on the surface of Mars right now. Right at the top, you can see a thing that looks like a little white radio antenna, which is, by the way, precisely what that white thing is. That radio antenna is communicating with the Earth already. The Deep Space Network is picking up signals from it. And about 1 hour and 7 minutes from right now, they anticipate that there will be a stream of data. They are calling it digital data, and they're saying it may not have photographic quality representations, but it will be able to tell us what the weather is like on Mars right now, coming from that antenna down here to the Earth. There's another antenna, a larger one, looks more like a satellite dish, which will try to line itself up with the Earth and then start beaming back massive amounts of data to the Earth, which would mean that by 3 hours from now, the first color photograph, a huge panoramic view of the Martian surface, would be beamed down here to the Earth. This is what happened over the past 3 hours since this thing broke through the Martian atmosphere and bounced around on its balloons on the surface of Mars. Actually, this is what's happened in the past 45 minutes. There was another big cheer at Mission Control at the Jet Propulsion Laboratory when there was confirmation that this sequence of events was taking place. Now, that particular dish antenna is looking for the sun. As soon as it finds the sun, which we think it will do any minute, it will begin beaming a stream of data, a high-speed stream of data down to Earth. Streams of data don't sound very sexy, but the pictures that go with it will be, we are told. The next thing that's going to happen today is that this little six-wheel robot will turn on its laser beam eyeballs and its TV cameras and will begin moving out over the Martian surface. The way this thing works is when those laser beams are interrupted as they reflect back into the rover gets a message that, hey, there's something we need to worry about. And according to Donna Shirley, who is the mission manager for all of the Mars exploration missions, this thing thinks like a bug rather than a human. It has been given the artificial intelligence of a cockroach. What a cockroach would do if it went up to something like this on the floor is it would bang into it, then turn around and work its way around. That's what the rover does. What you just saw happen, the thing that looked like a coffee can coming out of the side and touching a rock, was actually taking a sample of that rock to find out what it is made of. And that's the main job of this Sojourner rover, as it is called. It goes around on the surface of Mars, looks at rocks, and tells people down here what the rocks are made of. There may be some practical application in all this. For years, people on Earth have said, we bet there's some things on Mars that could be used for fuel, either fuel for rocket ships, fuel to keep people alive during the cold period up on Mars, and that's what the Sojourner rover will try to find out on this trip. What are those rocks made of, really? Are they things that could be broken down in a chemical analysis and things like that? So that's what's going on the surface of Mars. At the beginning of your show, Hillary, you showed some pictures of cheering people at the Jet Propulsion Laboratory. The human emotion of this is a lot neater, really, to me at this point in my day than all the nice animations and things. Let's go back to that again and just look at these people. All of them are technicians and engineers, not the kind of people who hug and kiss each other at work all the time. And just look at their reaction when all this unfolded just a few hours ago. The guy in the white shirt in the middle, one of the chief scientists on this project, been working on this for decades of his life. He is obviously ecstatic that everything is going so well. The miracle to me in all this...
John, I just want to jump in for a second.
Sure.
You say he's been working on this for a decade. How long? I mean, we know it's taken 7 months for Pathfinder to make it to Mars, but how long, actually, have people been working on this project?
On this particular rover, this particular idea for getting to Mars, it's been about more than 5 years. I was talking here on CNN International with one of the program scientists a few hours ago, and he said that he got the plan, minute by minute, what was going to happen on the surface of Mars 4 years ago. And they have been tinkering with that plan, fine-tuning it, making sure that they had all the equipment to do the things they wanted to do for that long a period of time. you can only launch things to Mars every 2 years, and it's a pretty narrow window. End of November, beginning of December is when you can launch things from the Earth that'll make it to Mars without using up more fuel than is possible to put in the rockets to ship them there. So they have 2 more years of work to do before the next round of satellites goes up to Mars, and they're working on them and have been for some years in the past as well.
Well, I know we'll keep coming back to you for more news on this particular mission, John. Thanks very much. John Holloman joining us there from CNN Center in Atlanta. And we will have much more on the Mars mission on Insight in about 20 minutes. Then about an hour from now, the first data is expected to be transmitted, and we will have live coverage. But now, another bit of space news. Russia's mission control is giving the crew of Mir, the space station, an extra 6 days to prepare for repairs. Russia's most famous cosmonaut, Sergei Krikalev, will be the chief advisor when the repair work begins in less than 2 weeks. For now, Krikalev is leading training exercises at Russia's Star City, simulating the repair work underwater. A collision last week damaged the Spectre module and some of the solar panels that help power the space station. Well, in the Balkans, the split...
A weak signal, a modest celebration, a daunting challenge achieved. Scientists learned Pathfinder made it to Mars in one piece and should soon be sending back pictures. Hello and welcome. If there is life on Mars, it may have reason to be alarmed. Just a short time ago, a box bundled in balloons came hurtling towards the planet. It slowed from the speed of a rocket to a bullet and then slammed into the surface about as fast as a car with no brakes. And it all went according to plan. On our program today, Pathfinder and the mission to Mars. We begin with CNN's Mark Bernheimer.
It's a very good sign, everybody.
It was the moment they'd been waiting for, and it came right on time. Pathfinder landed, apparently safely, on the Martian surface.
We're sitting on the base pedal, which is the bottom of the lander, absolutely perfect position, absolutely where we wanted to be. The fact that we could hear it all the way to that point and get the signal is miraculous.
Pathfinder was the first lander designed to literally crash into the surface of Mars, cushioned by a cocoon of airbags. Assuming everything goes as planned, the rest of the mission will depend on Pathfinder's passenger, a pint-sized scientist, a coffee table on wheels called Sojourner, which will roll off the lander's blooming solar panels and begin the lonely task of exploring Mars. Through a camera and a high-tech soil analyzer, Sojourner is expected to answer crucial questions for scientists a world away.
You know, what is Mars made of at just the most basic? You know, here's this whole planet and we don't have a clue as to what it is, you know.
The Pathfinder project is not designed to look for life on Mars. Scientists already know the surface of the planet has no water, therefore no life. Any signs of life deep below the planet's surface would be well out of Sojourner's reach.
You need a dozen missions to be able to define the environments and then go to the very specific places where you could begin those very specific to answer those specific questions. Pathfinder's the wrong mission to do that.
But, say scientists, Pathfinder could be, and likely will be, the first step. Scientists know it's not quite time for celebrations just yet. At a relatively cheap price of $265 million, the Pathfinder project was built without backup systems. If anything goes wrong from this point on in, there will be no way to rectify that problem. Mark Bernheimer, CNN, Pasadena, California.
Joining us now from Pathfinder Mission Headquarters at the Jet Propulsion Laboratory in Pasadena is CNN's John Zarella. John?
Good afternoon, Jonathan. Everything here is going better than anyone could have expected. That's the real good news. Of course, the engineers here and the scientists are still, things can still go wrong. There's a lot of things that have to happen yet, but so far everything looks wonderful. None of them could be happier, and here's their bumper sticker, Mars or bust, and they made it. So I guess now the key is Sojourner, the rover, getting it off the lander later this evening, and that's going to be another exciting moment. We'll be building up to that throughout the day. And of course, one of the key people, and there are many, many of them in this mission, is Matthew Golombek. And Matthew is a project scientist, and we spoke last night, and as I said to you, you were so confident. You knew something everybody else didn't know. You guys made it, and it looked great.
The whole project knew it. We all knew that if you work this hard and you're committed to this with this amount, that it would work.
In that control room, give us a sense, if you can, I know it's difficult, what the emotions were as you were getting that data back from the vehicle that it was working?
I mean, elation, but almost stunned that we got the signal all the way down. We thought it would be weak. We figured it might not even be there. We might have to wait until 2 this afternoon to actually get the first true confident signal. And we got it all. We got the whole thing all the way down. We know which pedal it wound up on. We know exactly when the airbags retracted and when it opened up. And we got the low gain antenna beep to us, implying that our telemetry system's operating.
What is the next big event coming up, and when is that going to take place?
Well, we're waiting for the Earth to get high enough in the Martian sky for that low-gain antenna to send us actual data about the internal workings of the spacecraft. Is it healthy? What are the temperatures? Are the solar panels working? Is everything ready to go? And when we get that, we ascertain its health, we then decide to unlatch certain things and start it on its job.
Matthew, Matthew, real quick, first picture.
First picture expected around 4:30 this afternoon if we get
time.
Yes, if we get the high gain antenna, which is also another big step here.
Matthew, thank you very much.
Thank you.
Talk to you again in a minute. So, a lot of things for the viewers around the world to keep close tabs to. Big events still to unfold here throughout the course of the day. Jonathan.
John Zarella in Pasadena, thanks very much. I guess that first picture will come our way in 3 hours' time. When we come back, though, more on the Pathfinder and its passenger, that curious little cart called Sojourner. Stay with us. Welcome back. In order to put Pathfinder on Mars, NASA had to design a ship that could travel faster than 7 kilometers per second on its 7-month journey. And after flying through about 500 million kilometers of space, it had to enter the Martian atmosphere in just the right way or it would burn up or bounce off. And that was only getting it there. How did they do it? Joining us now is Kurt Grimal, a professor of aerospace engineering at the University of Oklahoma. He is also the man who designed all of the animations we've been looking at today. Professor, thanks so much for being with us.
Thank you.
Let me ask you first of all about the landing site. How did they choose where to put Pathfinder, and how close did they get to actually putting it there?
Well, they're torn between 2 different types of locations. One that's exciting and mountainous and deep canyons, but that's very dangerous to land a balloon type or an airbag type lander. The other extreme is a very flat, no rocks. They lean towards going to a river delta, so it'd be flat with minimal amount of large rocks.
Now, you say a river delta. They didn't land in water, though, did they?
No, they did not. But on the surface of Mars, there is large landscapes that looks as if a river had once run through it and gouged great riverbeds onto the surface. And then it empties out into a very flat area, and this is an area that they chose.
The way they landed was very peculiar. I've never seen any kind of craft come down with such a complicated sequence. They used parachutes and rockets and airbags. Why did they have to go through that whole complex procedure?
The main reason is they did not have retro rockets to slow it down. They had to use every possible way to get it slowed down. The first thing was to use the parachute. In order to get rid of the parachute so the parachute won't fall on top of the lander, they had to have small rockets to push it away. In order the rockets will not affect the bags in any way, they had to have a tether to get it away from those rockets. And then after that gets away from it, they cut the tether and let it bounce and come to a stop by itself. You must remember, though, it was started at 7 kilometers per second or faster. And when the tether got cut, it was only going approximately 40 or 50 meters per second. So it had to slow down tremendously before it could even start bouncing.
How hard is it to land in a place like Mars? I've heard you say that there is a curse about the planet. Is it a tough place to send a craft?
For the last 21 years, all previous missions have failed, whether they didn't get out of Earth's orbit or they were lost just when they were going into the Mars orbit, and this is both United States and Russian spacecraft. So it's been kidded about a lot that there's a ghost out there that is stealing all the spacecraft, and so it's a great day when we finally get one through after 20 years of trying.
Now, we're getting we're getting callous about it, I guess. It's an amazing thing. We get so much information from space. We get live pictures from MIR. Our colleague here at CNN, Riz Khan, and callers from around the world. We're talking today live to the crew members aboard the shuttle Challenger. How much information, how quickly and how efficiently is Pathfinder going to communicate?
Comparing the Pathfinder to the space shuttle is, the distances are just enormous. It's like calling your friend across the street versus trying to call them across the country. The time distance is very great. Therefore, you need to design the mission such that you'll be able to have much of it work on its own.
I guess that really it comes down to very small amounts of information transmitted very slowly.
Think about 10 years ago, a modem was able to transmit maybe 30 bits per second. That is about how fast the low-gain antenna number 1, will transmit. The high-gain antenna will maybe get up to 2,000 bits per second, which is maybe a 5-year ago modem. We all get very frustrated on the internet with modems, and they're very slow. This is an extremely slow modem if you look at it that way.
Okay, we'll be getting news slowly, and a lot of people, a lot of scientists are going to be wondering about the passenger Sojourner. Can you tell us about it? How fast will it be going? How big is it? What exactly is it going to be doing out there?
It's only going to go to a distance of maybe 10 meters away from the lander during the first 7 days. This is the completion of the first phase of the rover. It will only move at approximately 1 meter per minute at the very most. It's more likely going to be moving at centimeters per minute.
How big is it?
It's kind of like a microwave oven or a small appliance, approximately a half a meter long, maybe a third of a meter wide, and maybe 10 to 12 centimeters high.
Now, people looking at the animation that we were just showing saw what looked like laser beams coming out of the front of it. You designed the animation. Was that creative license, or is there going to be some kind of beam coming from it?
Actually, there will be beams. There's 5 of them, and they use these beams to be able to detect rocks, where they're at, and approximately how big they are, so they can decide whether to go over them or around them. And this information is fed directly into the rover. It's calculated, and then it decides whether to go around them or over them, with very minimal amount of input from any operator on Earth.
Now, Mars is a tough place to land a spacecraft. Is it an easy place to run a car? Is Sojourner going to find the conditions there friendly to it?
No, it won't. That's one of the main design criteria of this and engineering tests, is how can you travel on a sandy soil? The animation here doesn't even show how sandy it really is, but you could sink your wheels up to a couple of centimeters into that soil, and to be able to keep moving and not get stuck is rather difficult. They've had a lot of practice with the moon. It has a similar substance to it, but it's hard to engineer. You'll notice it's not a rubber wheel, it's a metal wheel, and the sand can actually go up and around the wheel base.
Now, I'm from Canada, so I know what it's like to start a car in the winter. What are the temperatures going to be like for Sojourner?
It'll be as low as 100 degrees centigrade below zero and as hot as 40 degrees centigrade above. The higher temperature is not a big concern, it's those low temperatures. When you put batteries in low temperature, it's very hard to get the energy out of the battery. They have to keep those batteries warm so they can keep the energy coming from them.
How long are those batteries going to last? It's funny, it seems like they're sending a toy up there and just waiting for the batteries to run dry like any kid.
The mission is planned for 7 days, and the batteries will be sufficient to go through that first phase of the mission. They will hope that the solar panels will be able to recharge them and add additional power to the system to extend the mission for 2 months. That would be ideal. Then, on top of that, if it really works well, they might be able to get a whole year's service out of the rover.
Oh, we see the car. We know how it's going to be fueled. Who is going to be steering it?
It'll be a combination of its steering itself and the operators on Earth at the Jet Propulsion Lab determining where they want to go and analyze the soil. They'll basically pick out a point and then put that coordinate into the rover and tell the rover to go there. The rover will try to pick its way around the rocks or over the rocks to get to it. If it comes up to a difficult situation, doesn't know what to do, I'm sure it'll call home and ask for further instructions. But most of it will be done on board the rover.
Let me ask you a question as an engineer. How does this particular mission compare to the one that put men on the moon?
That's a difficult question. The 2 programs are so vastly different. One is a manned and one is an unmanned. The rules are completely different when you don't have to worry about a human being part of the mission. On the other hand, it's a much farther distance. And the more concern is it was a very limited budget, $175 million, where the Apollo missions ran up to the tens and 20 of billions of dollars. So the cost magnitude is just vastly different. We've gotten a lot more bang for the buck out of this mission than I would say we got out of the Apollo mission.
Now, one thing that does come to mind is that Sojourner is a very simple-looking machine. It has to achieve extraordinary things, but it's not going to be doing very complicated things. Was most of the effort put into just getting it there, or are they hoping that once it's there, it's going to really achieve extraordinary results?
They're trying to do an engineering analysis of how well these rovers or future rovers will work on Mars. It's critical that they know how to get around on Mars for the next 9 missions. They have a lot of testing of this engineering that needs to be done, and that's the primary focus of this mission. They have to do it sometime, and that's what they're doing now, is testing out how to get around on Mars.
You brought us beautiful animations and extraordinary expertise. Dr. Kurt Grimal of the University of Oklahoma. Thanks so much for being with us.
Thank you.
When we come back, a conversation about the next steps. After Pathfinder, there are a lot more plans for the Red Planet. Stay with us. Welcome back. Sometimes it's easy to let time pass without visiting even your closest neighbors. In Earth's case, it's been 21 years since we've sent anything over to Mars. But that's changing. Joining us now to talk more about that is Wes Huntress, Associate Administrator for Space Science at NASA. Dr. Huntress, thanks so much for being with us.
My pleasure.
An extraordinary achievement getting even this far, but this is just a first step, I take it. How much is NASA trying to find out about Mars, and how much is it planning to do to learn all that?
Well, it's really very wonderful to know that what we have is a sustained program for exploring Mars. This is not just a single mission, it's just the beginning of a set of many missions. We'll send 2 missions every 26 months when the planets are properly aligned. One an orbiter, one a lander, just as in this case, ultimately to learn lots of things about Mars. One, is it suitable for human exploration in the future? Where is the water? How much of it does it have now? What's the climate like? And how does Mars fit into the family of planets? And why is it so similar yet so different from our own planet?
Are all of the probes going to be like the one that's just landed there? Is it going to be simple machines like Sojourner on each of these trips?
They're all relatively inexpensive missions, designed with the newest of technologies and done in many innovative ways, just as this landing was done in a very innovative and very inexpensive way, and apparently quite successfully. Each of the landers will be different. We will send them to different places to learn about the different places on Mars. We'll send a series of orbiters to complete the mapping of the entire planet so that we can select the right places to send our landers. And ultimately, in 2005, we expect to launch a mission to return samples from the surface of the planet.
Now, you bring up the question of mapping. We have seen maps of Mars. School children can find them. I saw a globe of Mars. How much remains to be learned about just what the face of the planet looks like?
Well, the last time we did global mapping was with the Viking missions in '76, and they were simple cameras. What we're doing with these orbiters is to map the geochemistry, the mineralogy of the surface, the topography, the variation with height, so we know how high things are, how low things are. And we'd like to find those singular places on the planet that might be most interesting to visit it. For example, if we could find evidence of an ancient hot spring, where we know very simple life seems to abound on this planet, or places that might have rocks of the type just similar to the Allen Hills meteorite that we learned about this summer.
Well, you're mentioning visits, so let me ask you more about that. Realistically, how soon do you think it's going to be before people end up going to Mars?
Well, that's one of the reasons why we're spending so much effort at exploring this planet. Because one, we want to find out if it remains as interesting a planet as it seems to be now in terms of being a place for people to go to and holding out that carrot that life may have once started there. And we have to learn what it's like on the surface, and that's what these landed missions are for. What's the soil like? What's the atmosphere like? And can we, in fact, make fuel, oxygen, and the kinds of resources that human beings need out of local resources so we don't have to carry them there. And this could take about 10 years or more of research on the surface of Mars, at which time we'll be ready to make a decision as to whether to go or not.
When lay people think about Mars, they inevitably think about Martians. The question of life, either now or in the distant past, has come up, and some scientists think there's evidence of it. Is it possible that Sojourner or one of the vehicles like it in the foreseeable future will find more evidence that's relevant to the debate just by looking around on the dirt of the surface?
Mars Pathfinder wasn't designed to look for evidence of life. Later landers will be designed to look for the kind of chemical signatures and mineralogical signatures in these rocks that would pick them out as the kinds of samples we'd want to bring home. But what Pathfinder's Sojourner rover will do is, for the very first time, unlike the Viking lander, have mobility and go out and select rocks, look at them very close up, see if any of them have been formed by sedimentary processes during ages when Mars might have had standing water and lakes, to learn more about the history of Mars and the kind of material that might have allowed Mars in its past to have generated life, and the kind of material we'd like to go back and pick up someday.
We know a fair bit, or people like you, I should say, know a fair bit about the moon. You're now in the process of learning more about Mars. Can you just keep going on like this? Are all of the planets just waiting for people to end up sending technology or travelers to go visit? Or does Mars, for some reason, represent the last thing that we can realistically hope to discover?
Oh, by no means is Mars the last. Mars is the first. Mars has a particular place in the mind of man because it's so prominent in the night sky, and the ancients used to watch it crawl across the sky and assigned its very mysterious characteristics because of its blood red color in the sky. And in this century, the ideas of there once perhaps have been life there have certainly generated a lot of interest in it. But we're finding the solar system beyond Mars to be quite interesting in itself. For example, Europa, this ice-covered moon of Jupiter, may have an ocean underneath that frozen ice, and we're going to try to find out if that's true. And if there is an ocean there, I think that will be another interesting place we'd want to go to.
Well, hopefully we'll be talking to you again then. Dr. Wes Huntress of NASA, thanks so much for being with us.
My pleasure.
One final note before we go. If you want to see the very first pictures to come back from Mars, one of the first places you'll be able to find them is on CNN's special website on the internet, located at cnn.com/Mars. Stay tuned to CNN for the latest on the Mars mission. Coming up in a few minutes, a live report from Pathfinder headquarters with the first pieces of data from the red planet and the first pictures we expect in some 2.5 hours from now. That is our program, though, for this day. I'm Jonathan Mann. Thanks for joining us. The news continues in just a moment.
Particularly exploration of the red planet Mars. Let me show you what people on the ground at the Jet Propulsion Laboratory in California are able to see right now as they walk around the news press room. It's a picture, actually it's an identical rover to the Sojourner rover that is available at Mission Control out there for them to look at, planted in a sandbox. We're
just a few minutes away from the beginning.
What they're telling us there is that in about 8-9 minutes from now, we're going to get the first stream of data from Mission Control, from the Mars Pathfinder, back here to Earth. Earlier in the day today, about 4 hours ago, the Mars Pathfinder entered the Martian atmosphere, and when it did, the scientists on the ground were expecting to lose the signal from the Pathfinder. That did not happen. In fact, they got continuous signal until it bounced around on the ground and began to set up shop. Here was their reaction to that. And then a short time later, there was another announcement that the antenna was continuing to send not one, but two streams of signal from the surface of Mars back to planet Earth. That provided another reason for extreme excitement in that mission control room.
EDLCOM report signal detect on both subcarriers.
We've confirmed that the spacecraft has now completed pedal deployment, and we're transmitting our final semaphore on the low gain antenna. We now expect to get a signal in the spacecraft at 2:09 Pacific Daylight Time with real digital data. Stay tuned for more excitement from Mars Pathfinder.
Well, 2:09 Pacific Daylight Time is 6 minutes, 26 seconds from right now. Out there at the Jet Propulsion Laboratory, my colleague John Zarella is standing by. John, what is this digital data going to tell people, do you think?
Well, John, the hope is that it will give them the status of all the systems and subsystems, the engineers here and all, that the vehicle is healthy, that everything is working, and that then they can proceed on with the next steps of the mission. Everything has gone just absolutely beyond anything that the engineers could have expected here. And I'm getting a nod of agreement from Donna Shirley, who is, of course, the director of Mars exploration for NASA. And Donna, you've got some, well, toys, I guess, that we've got here. The real thing is up there. And
yes, it is.
To give the folks out there an idea of where we stand right now on Mars, what is the situation?
Okay, the situation is, if we can focus in on this toy, this is the lander. Now, this doesn't have the airbags on it, so the real lander has these airbags sticking out. When we landed on Mars, we actually came in and landed and bounced and rolled and tumbled and came to rest on the bottom of the spacecraft, which
couldn't have been better.
Couldn't have been better. Absolutely perfect. See, we could have, even if we landed on the side, still opened up to the bottom, but we didn't. We landed on the bottom. Then we got a signal that the airbags had been fully retracted. That is, the airbags had little strings inside them and a little fishing reel that reels them in and pulls them up tight up against these, up against the pedals. In fact, here's a piece of airbag material, so you can picture it there. Then the pedals opened up like this, and we know that it's opened up, and we know that the rover is sitting on one of the pedals like that. And the next thing we're going to hear is the data that says, okay, we made it down, here's everything that happened to us on the way down, and that all the subsystems and the rover are healthy.
All right, what we're going to do is throw it back to Atlanta, to John Holloman, and try and take a break here for a minute so that we can get back when all of this exciting information hopefully starts to flow back down to Earth.
Good.
John, back to you.
All right, Donna Shirley, John Zarella, thank you both. We'll take a quick break. We'll be right back, and perhaps when we come back, we'll know things about things going on Mars that we've never known before. Stay with us. Here's what's coming up. First pictures from Mars, 7:30, about 2.5 hours from now. First weather report at 9 o'clock Eastern Time. Color horizon picture, the big picture, coming up at 9:30 p.m. Eastern Time. Quickly, back to the Jet Propulsion Lab, where John Zarella and Donna Shirley are waiting for the first data for Mars, which should begin arriving in 52 seconds. John, you know, and one of the interesting things, too, about Mars, this first sunset may be blue instead of red. They said there's some possibility.
That's what Peter said.
Yeah, Donna Shirley is with us. And just to give our viewers an idea of just how small everything is, tell us what that is.
Okay, this is a stretched-out radio. And this is a commercial radio modem built by Motorola that we have qualified to go to Mars. And when folded up, this thing is the size of a cigarette pack. And we have one of these on the rover, and we have one on the lander, and that's how the lander and the rover talk to each other. They're not actually connected at all.
And this is one of the ways you're able to do these missions faster, cheaper, better.
Right.
Everything has gotten so small and compact.
Right, and we're being able to take advantage of commercial technology is also very important.
So, John, you can see that we've got our little micro circuit here. We've got our rover, and now it looks as if all we've got to do is wait here for the signals to come back from Mars to let us know that all of these things are working and working properly. And then you can move on to the next step, correct?
Right, that's right.
And what will that be then? What do you do?
The next step is that the lander camera is going to locate the sun, and then the high-gain antenna here will swing up and point to the Earth, and then we'll be able to send back a lot of data so that we can actually see pictures.
Mission control right now. I think we can hear what's going on there.
Can we?
Are they still waiting,
Ready?
Donna? Can you tell?
Oh, here we go. Are they talking?
They're not saying much, Donna and John. I'm looking in on mission control while you were talking with our viewers.
Okay.
But everybody's pulling out their home movie camera and their home still camera. A lot of it looks like high school reunion time actually in mission control.
Of course, it's a 10-minute delay, right, in time, and these things are not precise.
No, these are Earth receive times.
Earth receive time.
It is not precise.
I'm looking at a computer screen in mission control right now, and it looks like there are some streams of old data on it, and people are beginning to gather at a couple of these screens, hoping that they're going to see some new data when it comes in. There's one man in there who is making a home movie of the computer screen, so when that first data begins to come down on the screen, he will have it for his grandchildren.
Okay, well, why don't I talk about what's going to happen?
When you get it, it doesn't necessarily mean for the viewers out there that there's anything wrong because they're not hearing anything right now.
Absolutely not. In fact, we don't know exactly when anything is going to happen. The 209 was the earliest time when we'd expect the data back. And it could be that, because of conditions around the spacecraft. For example, if the spacecraft landed where there's a big hill next to it, we have to wait for the Earth to get up above that hill before we'd be able to hear it. So it might be as long as, 30 minutes to an hour before we actually get it back. This was just if everything was nice and flat.
And then what happens?
Then it will send back a signal saying, okay, here's what happened to me on the way in. Here's all the bumps and lumps and the parachute being deployed, and all those events will be captured, plus all the health of the systems, including the health of the rover and the health of the lander electronics, because the rover will send its data, says, here's how healthy I am, to the lander, and then the lander over this low-gain antenna, this little stalk here, is going to be sending that back to Earth at a low data rate. So this is our first downlink, and it really depends on when the Earth gets up above the horizon.
Now, I understand I was talking to some folks about the airbags, for example. You'll even be able to tell how far you bounced, how high you bounced.
Right.
That's amazing.
Yes, well, there's accelerometers in here, and every time you bounce, there's a hit on the accelerometer. And so once we know how many bounces, and we know how far apart they were, and we know where we ended up, then we'll be able to tell how far we actually went.
Donna, do we know anything about the atmosphere on Mars? I mean, what it is made up of, and will we know more after this data comes back from Pathfinder?
Well, we know that the atmosphere is almost entirely carbon dioxide, and that it's approximately 1% as dense as the Earth's atmosphere. Viking told us all that very well, and we won't add to that. However, what we will add is what it was like coming in, because we only have 2 holes in the atmosphere that have ever been bored before, and that was by the 2 Viking landers. So this is a 3rd hole that's being bored in the atmosphere, and we'll be able to compare the things that happened on the way down. Will tell us how thick the atmosphere was at different parts of it, and maybe which way the wind was blowing and what the temperatures were. We really get a lot of information about the profile of the atmosphere as we came through it.
Does that
information?
Go ahead, John. Excuse me.
No, I was just going to say, John, I think that information is really going to be critical, isn't it, to future missions?
Yes, it is. It's especially critical to our future landers, but it's also important for Mars Global Surveyor. Mars Global Surveyor is going to go into orbit in September, and instead of going right into the low mapping orbit, the low polar mapping orbit that we want to be in for our 2-year mapping mission, our 2 Earth year mapping mission, we'll end up in a big loose orbit.
That we have symbol sync and we're waiting to get frame sync. We expect that to happen in 5 to 7 minutes.
Frame sync in 5 to 7 minutes.
Which means?
Which means that that's when we'll start to get the data.
Digital data.
When we do frame sync, we'll have digital data. What that means is the data is coming into the Deep Space Network, and it's kind of going beep, 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 beep in little bits.
So it is coming in now. Now they know it's coming in.
They know it's coming in, but they don't know what the content is. Then it has to synchronize up so that the data comes in little packets of information, and those packets have to be synchronized so that it reads the right time to start and the right time to finish, and that's called frame syncing. And so that has to happen before we can understand what the data tells us.
But that's another good sign, isn't it, that the information is, they're getting it?
Yeah, the bits are starting evidently to come in, and it's just a matter of synchronizing the radio on the ground so that the information is being received properly.
Well, we've got some time now to wait, another 5 to 6 minutes,
Right,
and we're going to take a break from here. It's a lot hotter here, isn't it, than
Yes,
it is on Mars?
Yes, it is.
It's certainly not like this there right now.
No,
It's probably a little chilly. Might be
On Mars, it's about 100 degrees below zero right now.
I'm not sure which is worse about this particular point in time. But, John, we're going to throw it back to you right now and take a break here at the Jet Propulsion Laboratory.
Zarella didn't point out that I'm here in the nice air-conditioned studio while he's out there in the hot sun with Donna Shirley. This packet frame synchronization is the same way that you get email messages, because I've looked into the program for the email on my computer, and so that's sort of what this thing is doing, trying to send some email to the Earth. We'll be back with more of our live coverage in just a moment. Stay with CNN. This is pretty exciting stuff. planet behind me is becoming more and more clear to people on the ground. We're going to go back into the Jet Propulsion Laboratory where, Donna Shirley, I'm told we have a frame of data. What does that mean, and what do you think it indicates, and what is it going to tell us, a frame of data?
Well, a frame of data is one piece of information that describes, in this case, the condition of the spacecraft. So this is really exciting. This is the data we've been waiting for. This is the Mom, I made it, the safe arrival phone call. Yep. And this is what we've been hoping for. Yeah, and I can see Dan Golden, the administrator of NASA, Ed Stone, the head of the Jet Propulsion Lab there with some of your scientists, your team leaders. I don't know if you can see them on TV or not, but they are looking at that computer screen with great interest. And I know Dr. Stone is a man who has a lot of experience with computers, and Mr. Golden is a man who used to design spy satellites. So this kind of a day for the two of them, with all of their knowledge from their backgrounds, must be scintillating and exciting. And nobody's frowning. That's a good sign, I think. That's a good sign. I haven't heard a lot of screaming yet, though, so that's my indicator, since I'm out here on the mall instead of being in the control room.
One frame is not much, right?
One frame's not much, but if we got one frame, we got a bunch of frames.
How many frames is it going to take before you have a good feel? I mean,
you would ask me that,
wouldn't
ask you?
That.
Yes.
I'm sorry.
I don't know the answer to that.
A lot of frames.
Yeah, a lot of frames. Well, a frame is, John just described it beautifully a while ago. It's like email. And when you send email, it goes in chunks, like it'll show up, like when you're printing a picture out from the internet or some data out from the internet, you get a piece of it, and then you get another piece of it, another piece that shows up on your screen. Well, this is that same kind of thing. And it has to be synchronized so that the receiver and the sender are going along at the same frequency. And that's what syncing is.
I was just asking you a very non-technical question.
And I made it technical.
No, not that question. A question before. Would you have ever imagined the level of attention that this mission has got?
Well, actually, yes. I was the one that predicted 4 years ago that we would have this kind of attention, and nobody believed me. So I'm happy to be vindicated in this case. Now, what I just hope is that everything keeps going as well as it has gone in the past. So I'm waiting for the rest of those frames to come in.
Donna, Donna, go ahead, John.
Let's go back into the control room. Tell us who the people are in that picture. They are big. I see Ed Stone in the middle, the JPL director. You're a ship controller.
I can't.
There's a glare on our.
There's a glare on our screen.
Hard for us to see who exactly is in there. It looks like Jennifer Harris there is the one of the.
Yeah, it could be.
Jennifer Harris on the left, one of the flight controllers.
Okay.
Yeah.
Brilliant red
okay.
hair. Yeah.
That's Richard Cook on the far right. Brian Muirhead with the bald head next to Ed
We
Stone.
have.
All right, they got it. They got it. Woo!
Another great moment.
Another great moment. All right. There are so many great moments here. I don't know what they got, but they got it.
They got something.
Donna, don't have a heart attack. But
I'm not having a heart attack. I'm happy.
There are cheers all around. Maybe we can listen in to the mission control and see what it is they've got.
Good plan.
Yeah, no Chilton.
How's the day looking? Oh, broadcast 6 minutes.
Yeah, the computer screens in Mission Control are filling up with data. I can see it on the wide picture we have of Mission Control right now.
Flight software?
Go ahead.
Preliminary, no EBR warnings as of the first packet down.
Good. Keep in mind the packet time was 2052, just before S12 started.
That means everything's okay.
John, you might have heard just now, that was Donna saying that no warnings means that everything is okay in the first packet of information.
That's right.
And a packet of information
is some amount of bits that makes some numbers that tell us the condition of the spacecraft.
Of certain systems.
systems
Any
on
particular
the
systems that were coming first, the information first, or you have no idea?
I have no idea what order.
Do we have command mode on at this time? Yes, we do. Thank you.
Donna, that's real good news. Now, the computer inside the Pathfinder is designed to send you warnings if it detects anything wrong. It's kind of like your home computer. If you've lost a program or something, a little message will come up, and that's sort of what these packets of information are. Am I right?
So everything's pretty clean right now. Now the content, the controllers actually have to look at the data for a while to see if everything's within limits. Now they do have alarms that are set up so if something's out of limits, it would say, whoops, I'm too hot, or I'm too cold, or I've been stressed too much. And so far I don't think we have any of that.
It's kind of like when you get a big
This is
blood
Mars Pathfinder
workup.
Mission Control at the Jet Propulsion Laboratory.
Flight, can you give us an update as to when we expect to see DPT-9 active, which means we get data other than EH&A?
I believe we're going to get 3 more EH&A packets before we open up DPT-9, which then would start allowing the EDL maybe to...
Okay, I can't
understand what they were.
Mission Control at the Jet Propulsion Laboratory. Obvious exuberance in the flight control team when the data started to come in. Not only data, but they were not only the carrier signal, but they were actually receiving data. Now the team is back to business as they start to analyze that data and interpret exactly what the state of the lander is. Jennifer Harris, the flight director, in the center, and Richard Cook to the right.
They'll be telling you what the data is at the press conference, which I think is coming up at 2:30. And so right now we have to just kind of wait for them to look at the numbers on the screen, interpret those numbers, understand which
There's going to be a project statement
things
coming
are
up
right
in
and which
just
are
a
not.
few minutes
Then
from Brian Muirhead,
we'll be able
Deputy
to hear
Project
that.
Manager and Flight System Manager. This is Mars Pathfinder Mission Control.
Here comes Brian, as a matter of fact, with Dan Golden and Ed Stone. So
I wonder if we can get Dan Golden to come over here for a...
Well, Brian's more important.
Brian and Dan Golden. We've got to try and get them both over on CNN very quickly.
I'll talk while you go grab them.
The administrator. We know. We're on live right now, Mr. Administrator. 2 seconds with John Holloman. You got 2 seconds? Just 2 seconds. Very quickly. Very quickly. John Zarella, Donna Shirley, and John Holloman in Atlanta. This has got to be a tremendously... Well, I'll get out of the kiss. Grab this and talk to John. John, you have a question for the administrator? And maybe Mr. Administrator, a comment.
His reaction when those first frames of information
Your reaction.
Oh, this is wonderful. I was just over in the control room, and we had a grand total of 15 people, John, that were operating this spacecraft. And in the past, we had hundreds. And it landed, and when that digital signal came through, the sky opened up, and it was nice and clear, and the sun was shining.
And you proved that cheaper, faster, better works.
Well, we're not there yet. I want to be very level throughout this, and I also have to leave because I have to speak to the Vice President.
Thanks, Dan.
Thank you very much, Mr. Golden. Appreciate it. Well, that was good. I'll throw my mic back on here now, John.
Little target of opportunity.
Yeah, target of opportunity. We never seize an opportunity at CNN.
That's right.
Anyway, John, so he's on his way over. So that news conference ought to be starting in about, about 4 or 5 minutes,
Yeah,
Donna?
looks like it.
They should have some indication then of what the data is.
Right.
And how good it is.
Yes, I think it's going to be good. But I hope they've had time to at least look at it a little bit, because Brian left up there while they were still looking at the numbers. So,
well, that must be a good sign, too. He doesn't seem like that's the deputy project manager, right?
Right, the deputy project manager.
He seems to be pretty comfortable with what's going on.
Yeah. I think we're okay. I mean, at least so far it looks like we're okay.
How long will it take them? How much data will come in? How long will this downlink of data be going on?
This downlink of data goes on now. They'll be downlinking data the rest of the day until Earth sets. And Earth sets, I think, around 8:30 or 9 at night, tonight, something like that. And so we'll be getting a continuous stream of data. The next thing we're going to do is to see if the high gain antenna is pointed in the right direction. And then we can start to get back data at about 2,500 bits per second.
So you can do this simultaneously then. You'll be getting low gain data all constantly.
Well, no, I think we stop doing low gain, and if we can get it onto the high gain, then we send it over the high gain. Now, the data that comes in from the low gain is about 250 bits per second. And if you have a really kind of funky modem on your computer, it's at least 9,600. bits per second. So the low gain is very slow. But even the high gain is only 2,500 bits per second. So it's only about a quarter as fast as a really bad, not too good modem.
It's the one I'm working with in the computer
right.
back in the trailer right now. It's exactly what I'm working, 9600.
So it takes a long time to downlink a picture. As you know, when you try to downlink something from the internet, how long that takes. And so it takes even longer from Mars. And then we send them over to the image processing lab. And I was just talking to Bill Green, who is our image processing laboratory leader. And he said it'll only take them a few minutes to process the pictures once they get them back. And Peter Smith, the principal investigator for the camera, will be standing right there looking at the screen. And if the calibration is right and the colors look right and it looks like it's a good picture, then they'll send it right out and it'll be in the press conference, which is maybe they'll be, not the first picture. The first picture will be there at about 4:30.
But the world will see the pictures very quickly after you see them.
That's right. We put them right out on NASA Select. You guys can put them out to the world. That's why you're here.
We certainly will. We certainly will.
And they'll also go on the internet.
All right, well, John, we're going to go back to you now so that we can get ready for that news conference in just a couple minutes. John?
That's some good questions, old friend. All right, we got a few times to tell you about. 2 hours from now, first picture. Maybe a little bit sooner, we don't know yet. 9 o'clock Eastern Time, first weather report. 9:30 p.m., first color wide-angle picture of the horizon on Mars. And what we have been seeing just time after time after time, we saw just a few minutes ago as the first positive data came back from the Mars Pathfinder saying that everything on board was okay. Let's listen and look at the reaction there in the Mars Pathfinder Mission Control Room one more time.
We have
All right. That's it for our coverage from right now. Our journey to the Red Planet. A lot more to do tonight. We'll take a quick break. We'll see you very shortly. John Holliman, CNN reporting. What a 4th of July they're having at the Jet Propulsion Laboratory and all around the United States, where people who are interested in the exploration of the solar system around Earth's sun are seeing the first live data being beamed back from the surface of planet Mars that's happened in about 20 years. A news conference is about to start at the Jet Propulsion Laboratory. Dan Golden, the administrator of NASA, just stopped by CNN's John Zarella's live position to let us know that the Vice President of the United States is out in California. Mr. Golden and the Vice President, as you'll probably remember, were live with us here on CNN yesterday afternoon at about this time. They'll be holding this news conference along with the mission and planetary scientists at the Jet Propulsion Lab, who have just gotten word that the Pathfinder space probe has every system that has been checked and has had information beamed back to the Earth is working just fine. John Zarella, before this news conference gets underway, you have been assimilating information for a long, long time today, yesterday, and in the previous days. There's nothing really going wrong here, is there?
No, and that's certainly a surprise to everyone. They had contingency plans lined out that if this went wrong, they would do this. They'd move to this contingency plan. And so far, none of that has happened. It has gone swimmingly, much better than, as well as anyone could have hoped. And the hope now, of course, is that it continues to move along in that direction, going as well as it has. In the course of events, something could go haywire at this point and from this point on. But so far, that's not the case. And, you know, I guess, Don, one of the things, we can't call this a spacecraft anymore, can we? It's a lander.
It's a lander.
I mean, it's on the ground. It's not a spacecraft.
Yeah, it's a lander and a rover. It's two spacecraft now.
It's two spacecraft.
It's thrown away some of its previous incarnations as a spacecraft, and now it's a lander.
All of those work perfectly. Nothing went wrong that you know of at this point. And now you move on to getting the lander, to getting Sojourner off.
Right. Well, the first thing we want to get back is we want to get the camera to look around and take a picture. And what the camera will do will point at the rover's pedals and then point around to see if any of the airbags have lopped over onto the pedals. Now, here's some airbag material. What we don't want is for it to look like that. We want all these airbags to be neatly tucked underneath. And once the airbags are tucked underneath, and especially around the rover pedal, then we know it'll be okay to stand the rover up, to deploy the meteorology mast, which is over on this pedal, and then to unroll the ramps. And then the high gain antenna will be sending back some data. And if we get a good picture, then we'll know it's safe to send the rover off.
And these are solar panels, which is another reason why you don't want any of this
Right.
material over the top of it, right? That
That's
would
right. All the power comes out of these
right out
pedals.
of these pedals. That's the solar panels.
And we need to get the rover off because you can see the rover's sitting on top of some solar arrays.
Some of the solar
so
arrays.
it's actually blocking the solar energy. So not only do we want to get the rover off so she can go to work, but we want to get her off so she's not blocking the solar arrays.
Hey, Donna, it's John Holloman just jumping in for a minute. If everything goes just the way you want to, how many different pictures of Mars will we have? I can't finish the question. The news conference is underway. We're going to go there. I'll ask you when we get done.
Our first telemetry from the spacecraft. This is way beyond our expectations. The whole day has just been extraordinary. I don't think any of us expected today to go like it has. Every time we looked for the spacecraft, it was there. It gave us clear indications it was on the surface, that it was healthy within 3 minutes after landing. And now, just now, we received our first telemetry from the spacecraft. We're getting down the health of the spacecraft, and it sounds like everything is absolutely perfect. So we hope to be able to continue the day with images coming up soon, and then maybe even the rover. So I can't be any more excited than I am, and I know the whole team feels the same way. I suspect you guys share in this with us as well. Thank you very much for your support.
Mr. Golden.
What a birthday today. There's a lot of fireworks in the mission control room where I had the privilege of talking to some of the people who did this. And it's interesting. This is a revolution just of the type of the revolution that formed our country on the day of our birthday. The people who formed our country weren't afraid of taking risk. They weren't afraid of doing things differently, just like the Mars Pathfinder team. And they're doing just a terrific job. And you could sense the pride among each of them as they hugged each other. There's a tremendous warmth. It's just not respect, but it's a warmth. And I think this is going to change the history of the space program. Congratulations, Brian. And to you, Tony Spear, who's listening right now.
Dr. Stone.
Well, what a way to celebrate the 4th of July. Doing what no one has done before. That's what NASA's all about. That's what JPL is all about. And I think today the Pathfinder did what no one has done before. And of course they have a number of days ahead now doing things that nobody has done before because nobody could do them before. So it's, again, congratulations to the team that made it all happen. It really has kicked off a new era of Mars exploration, which is going to be a very exciting period for everyone.
Now we'll start with Q&As. Seth? Do we have a microphone? Just go.
Seth Borenstein, Orlando Sentinel. Do you know where on Mars you are, how close you are to good rocks or stuff yet?
No, we don't. And we won't know that until we see our first images down as far as what the terrain looks like. But we know we're down, we know we're very healthy.
Do you think you're in that last circle from before? Or?
Well within that. And we won't know until we've spent some more time with the ranging.
The phone is ringing here.
I think we might have a phone call.
Hello?
You guys just stand by.
Could be E.T.
Hang on if y'all stand by for a minute.
I'll hang up, you'll call back.
Problem?
You guys want to distribute the later?
The phone call is going to come from the Vice President of the United States.
Vice President?
We'll listen in.
Hey, Dan. Congratulations to all of you out there on behalf of President Clinton and all of the people of our country. Happy 4th of July, and congratulations on doing an absolutely outstanding job.
Well, I tell you, I'm here with the Deputy Project Manager and Ed Stone, the Director of the Jet Propulsion Lab, and I can't begin to tell you what a wonderful job these people have done for our country.
Well, congratulations, Dr. Stone and Brian Muirhead, and to all of the members of the team who've been a part of this magnificent accomplishment. The whole country is just very proud of what you all are doing and have done today, and what a great way to celebrate America's birthday and celebrate our country's know-how and ingenuity as we press forward to new heights and new frontiers. I'm very excited about this. I've been following this throughout the day and watched the cheering there when the signals came in when you were going down through the atmosphere, and like everybody else, I'm looking forward to seeing the images when they come through. And I know that not too long after you get the first images, you're going to be deploying the rover. And I had a chance, Dan, when you and I were out there, when I made the announcement on the new X-33 on behalf of the President, we got to see that model or that backup firsthand and how it works. And it's just amazing that so much technology has been able to, you've been able to put so much technology into such a small vehicle. It's really just a very exciting and historic moment, and I do want to congratulate all of you. And Dan, to all of NASA, this new way of doing business, faster, better, cheaper, is certainly being borne out by this dramatic success today. And keep up the good work. The President and I are both very, very proud of your accomplishments, and the entire country is just reveling in your success, and we all congratulate you.
Mr. Vice President, we couldn't have done it without the tremendous support you and the President have given us. You've been there at every step. You knew it was risky, but you trusted us, and we wanted to come through for you.
Well, you sure did, and I'll be watching very carefully, along with the many millions of others, as the images begin to come through, and as we follow the adventures of this vehicle going out onto the Martian soil. So we're all going to be watching carefully. Good luck, and congratulations again.
Thank you very much.
Thank you.
Thank you.
Bye-bye.
We have some more data coming back, I understand, so I think Brian probably has to leave, and we'll be back again at 3:30 for a more formal, extensive press conference. Thank you.
So, the more formal, extensive press conference without the staged phone call from the Vice President will be coming up in, well, just a couple of hours from now. And when it happens, we will be back with more live coverage. And there are some other things going on in the world we want to tell you about, too. That will be coming up as well. Stay with CNN. Great news. For the past 45 minutes, the Mars Pathfinder has been sending back data to computers on the ground at the Jet Propulsion Lab. That data has been fed into another computer that can generate a picture from the data of what is happening on the surface of Mars. And this is what the picture shows. This is how the Pathfinder descended through the Martian atmosphere and came down onto the surface of Mars. And there is a picture of what it looks like right now. Rather than having to go through contortions to end up in precisely the proper configuration, it landed with its bottom on the surface of Mars rather than one of those panels on the side. And now this Pathfinder is all laid out on the surface, ready to begin the next part of its job, which is the exploration of this red planet that is, if not Earth's nearest neighbor, the other planet close to Earth that is most like our own planet. It is happening right now. The scientists and engineers, as we say, have gone through these very joyful, jubilant moments time and time again. Here's the last one, when that data, which you just saw transmitted into a computer animation, was received in the JPL's mission control.
We have
Moments later, the administrator of NASA, Daniel Golden, stopped by CNN's live position there to tell us that this was not 100% vindication for his cheaper, faster, better policy of sending things that don't cost a lot of money out into space. But he said the news so far certainly was good, and he talked about the 4th of July, American Independence Day, as he spoke to a group of reporters at a news conference just after he stopped by our live position.
What a birthday today. There's a lot of fireworks in the mission control room where I had the privilege of talking to some of the people who did this. And it's interesting. This is a revolution just of the type of the revolution that formed our country on the day of our birthday. The people who formed our country weren't afraid of taking risk. They weren't afraid of doing things differently, just like the Mars Pathfinder team. And they're doing just a terrific job.
The three of the leaders of the space program that resulted in this return to the red planet were sitting there to take questions from reporters when all of a sudden the telephone rang. And guess who was on the other end of that phone line, Judy? The Vice President of the United States, who is also chairman of the President's National Space Council.
Congratulations to all of you out there on behalf of President Clinton and all of the people of our country. Happy 4th of July, and congratulations on doing an absolutely outstanding job.
So, right now what is going on is that more information, more data is being received at the Jet Propulsion Laboratory, where my partner, John Zarella, is standing by. John, have you heard anything more recent than what we have gotten in the past 15 or 20 minutes?
Well, we've got a little more information. I know you're big into computers, and I want to tell you that their website Meister was just by here a few minutes ago, and he was telling us they already had, just today alone, 8 million hits. And that's just right here on at their website right here. So that's a tremendous indication of the volume of interest out there in what is happening on the red planet. And what we did find out, and Donna Shirley is here with us to continue discussing this. I heard you had some more good news. Tell us about landing the 2-degree angle. What does that mean?
Right. Well, the Brian Muirhead stopped by on his way back from the news conference. The deputy project manager, and told us that the lander was tilted at only 2.5 degrees, which means it's flat as a pancake, so it's just perfect. And if the airbags have been pulled in properly, there should be absolutely no problem getting the rover off.
So there's a good indication now. I know I overheard Brian talking to you saying, we're going to get that rover off today, so things are really moving along well.
They're just incredible. Now, we just got the data back. The engineers still have to analyze it to make sure that everything's okay and understand the state of the spacecraft, but apparently everything is alive and well. We won't know exactly how much, everything is until some of the data has been analyzed, and I think the next press briefing they'll bring that information forward.
And that should be in about 20 minutes, 30 minutes or so.
Right. And I wanted to mention that that this website that got the 8 million hits is just one of about 15 sites that we have worldwide. I mean, everybody is mirroring for us. So if you can't get into the Pathfinder site, go to one of the mirror sites and you should be able to get in easily.
Obviously, tremendous amount of interest is still building as we move on towards the first picture. Everybody out there wants to know, first picture, what are we looking at now? When?
Well, that first picture is coming back around 4:30, and maybe by the end of the next press briefing, we'll have a picture. That picture is not going to be anything you'd want to write home about. It's just a little picture, just a very highly compressed picture, just to look at whether the airbags are safely tucked in or not.
That'll be that first image that we'll get. That's about 7:30 Eastern time, and if all that looks good, then they'll proceed on, NASA, the engineers here, to moving to the next step, which would be getting the rover off the vehicle sometime this evening. So, John, a lot of exciting things yet to come here from the Jet Propulsion Laboratory. John?
No kidding. You guys try to maintain your energy levels and not fall over out there. We'll be getting back with you throughout the night. Joining us here at CNN Center is Professor Kurt Grimal. formerly of Georgia Tech. While he was there, he came up with all the terrific video animation that we were able to show you before the Mars Pathfinder landed on the Martian surface. Doctor, how are you feeling at this moment?
Oh, it's just wonderful to see everything that has been planned come to fruition. 100% successful so far. They only have about maybe 40% more to do today to have 100% completion for the day.
Yeah, now this rover, you've got a model here that it shows pretty much what's going to happen. The fact that the Pathfinder is not tilted, it's just about, as Donna Shirley said, flat as a pancake, means the rover is going to be able to start its work pretty easily, correct?
That flatness means two important things. First of all, that the sunlight, when it does come up, will be hitting this evenly, so they'll be able to get power on these solar panels. The second one is that if it's flat, it'll be able to roll off very easily.
Yeah. Now, how far can the rover go?
They're going to plan for the first 7 days to be able to go up to 10 meters away from the lander area. The next 2 months, they'll try to go out even further. And if they're lucky and have everything work properly for the 2 months, they'll try to go for 1 year, in which they'll go out even further.
Wow. So they can't plot. I mean, on the surface of Mars, this is a Martian globe that you have brought in. Show us in general where the landing zone is and where, I mean, how much of that could the rover cover, given that it's in reality, it's only about this long and the wheels are fairly small, and even if they were spinning fast, it couldn't get very far.
Well, for the audience at home trying to locate it on their own Mars globe, I'm sure everybody has one. If you find a large canyon area, it is to the right and a little further up in an area right here. Now, the area in which this rover is going to go is so small, my finger would cover the whole area. It's hard to show it. Even a pinpoint is about all the area it's going to cover by this rover. But what this technology is going to show is that they can move a rover around the surface of Mars, and hopefully on the third and fourth, maybe fifth mission back to Mars, that'll be happening in 4 to 5 years, that they'll be able to even go kilometers away, maybe even 100 kilometers away.
Kurt, our viewers are asking, how big is Mars compared to Earth? If you put them side by side, Earth would be about twice as big.
That is correct.
And if you were going to look in the night sky tonight and try to find Mars, which way would you look? That may be that's a question you were not prepared for, but what can
I'm
you
going to have to plead innocence on that one. I'm an aerospace engineer, and not a planetary scientist.
All right, I'm going to find out. And next time we come back, I'll tell you which way to look from wherever you are in the United States or around the world to pick up the red planet. One thing about it, during the days of the Hale-Bopp comet, when my 4-year-old and I went outside and pointed our binoculars up, long before we saw the comet, we saw the bright red planet. It is not hard to spot. It's the reddest big thing in the sky anytime you point your binoculars or telescope up that way. Judy?
All right, John, we're going to tell us exactly where Mars is in the heavens the next time we talk to you.
It's a deal.
Thank you, John Holloman. NASA will hold its next news briefing a little later in our program. CNN will bring you that news conference live at 6:30 p.m. Eastern, 3:30 Pacific. Hillary?
Thanks, Judy. Well, not focusing on Mars now, but something else. Russia's...
Hi, it's John Holloman at CNN Center, about to take you to the Jet Propulsion Laboratory in California, where there's about to be another news briefing on the Pathfinder mission to planet Mars. The information we have been given so far is that for about the past hour and a half, computers at the Jet Propulsion Lab have been receiving data from Pathfinder. They have used that data to paint a picture of just where it is, or at least how it is oriented on the surface of the planet. They are hoping to get a weather report from Mars very soon. This is the orientation of Pathfinder on the surface of Mars. If you look very closely, you can see some blue and red lines which represent the surface of Mars. This is how it looks right now, which is precisely the way it is supposed to look. It is only 2 degrees off of the perfectly horizontal orientation for the solar panels that are just beginning to receive some sunlight from the very early morning sun coming up on the landing site on Mars, as those solar panels charge the batteries on board the Sojourner rover, as well as the mothership Pathfinder. There are going to be some spectacular pictures which may well be sent back to Earth. Joining me from the Jet Propulsion Lab to talk us into this news conference, CNN's John Zarella, a man who's been to more space launches than anybody else at this joint. How does this compare to watching the space shuttle go up?
Well, you know, John, the space shuttle is always an exciting event when it lifts off. There's no question about that. I've seen probably 60 or 70 of those, and every one is spectacular. But there is certainly an unbelievable degree of drama going on here. It's funny, you know, we can't see any of what's going on yet, but the drama is there, and I think that's what makes this story so amazing. You know, some of our viewers have wanted to know out there, well, exactly where is Mars in the sky if they go out and take a look? And Donna Shirley, where can we see Mars? Can we see Mars right now?
Well, we asked our project scientist, and he didn't know. But then we asked the guy who programmed the computer, who did all the software, and he said it's low in the western sky.
So very low on the horizon, so it'd be pretty difficult for folks to see this time of the year.
Right. Maybe they can see it right after dark.
Some new information that we can get out very quickly before the briefing starts about what happened that you know now during the descent and landing.
Right. As far as we know, there were 3 bounces, and it took just 3 bounces, which is a very small number of bounces. And the first bounce was 18 Gs. That's 18 times the force of gravity. The second bounce, I think, was 9 Gs, which is nothing. And then it rolled for about 92 seconds and then stopped. And when it opened up, it was absolutely flat, 2.5 degrees tilt, which is absolutely nothing. So that was really incredible news. Now, we have qualified these systems to land at 55 Gs. So
means it was a very soft landing, right?
Very soft, gentle landing, which must mean that the radar altimeter worked perfectly and the airbags were cut loose just very low above the ground, and so it's just absolutely couldn't be better.
So all that animation that we have has to be redone now, right? Because it has it bouncing around too much on the surface before it comes to rest.
Right, we'll redo that.
Now you're going to get some of the information in that. Now we also heard just recently that that first packet of low-gain downlinked data about the health of the spacecraft is in.
Yes, it is. And as far as we know, it's completely in, and the engineers have been analyzing the data, and I think that's going to be the subject of this next press conference. And so, as far as we know, all of the systems are healthy, including the rover systems. So all the spacecraft seems to be working just great, and we're ready for the next step, which is to get the high-gain antenna pointed at the Earth.
We're going to go now to the presser. It's starting, so we're going to switch now on CNN to the presser.
Right.
How appropriate it is that we also start today a determination to be the masters of the science of our solar system. It is wonderful. I just want to spend a few moments saying how proud I am of these young people who are sitting on my left and those who think young that are over in the mission control and worked on this program across the agency. And I also would like to take this moment to thank the American taxpayers who have had confidence in NASA as we've gone through all these changes, and they stuck with us because it is their program, it is not our program, and we at NASA celebrate you for believing in us. Being a different kind of program, I was here in the spring, and a young man, Kirk Goodall, came up to me and said, Dan, we can't be on the internet because we're going to get too many hits. He said, I'm concerned because we only have a capacity for 5 to 10 million hits here at JPL. So I authorized him so that every person in America who wanted to turn on to the internet to watch this mission could do it. And he informed me we now have a capacity somewheres between 75 and 100 million people to tune into the internet, and they told me that by about 5 or 6 o'clock today they anticipated 40 million hits. This is exciting. We are now really in the electronic age, and I'm so proud that we could get this information to everyone who wants to see it. So let me at this point turn the program over to the real people who did it and tell you and all the people who work for you how proud I am, the Vice President, the President, and the American people, the people who allowed us to sit up here. Thank you very much.
Okay, well, I don't think I need to tell you how amazingly happy the flight team is, not just us, but our friends and family who are here. This is really a spectacular day. It's gone better than we really possibly could imagine. Sometimes we're pinching ourselves saying, is this real? Is this really real? or are we doing a simulation? But no, the lander is on the surface of Mars, and we're getting data back from it. It looks very, very good. The rover is also giving us data. I'll give you some more specifics in a minute. But I think this is definitely, I'm sure I'm speaking for everybody on the flight team, Tony Spear, Brian Muirhead, that this is definitely an experience that all of us will remember for the rest of our lives, that this is really special, and that we're on the surface of another planet, that we'll get to explore it over the next few weeks and months, and we will learn a great deal about both ourselves and our solar system. So we're really pleased. Let me just give you some basic statistics about the status of the lander and the rover, just so that I think most of it's gone on over the net, so you've probably heard it, but I'll summarize it. Jennifer Harris and the flight team are doing an excellent job of assessing the health and status. Basically, we do know now that the airbags are fully retracted and the pedals are deployed. Rob will talk more about the entry, descent, and landing process, what happened during that phase. But in the end, the lander appears to be tilted about 2.5 to 3 degrees, which is quite flat. In fact, we were having a little pool there at the last minute as far as what we were betting, and it was a little bit lower than what we were guessing. We routinely in our simulations get angles up at 10 or 15 degrees, so this is great that we're basically flat on the surface. The battery state of charge, which is a very important parameter for how well we're able to continue doing surface operations, right now is at 76%. Again, that's beyond what we thought it would be. We didn't use as much power or energy during entry, descent, and landing, which leaves more for surface operations. So there again, we're very pleased. The solar arrays are producing power on the lander. Obviously, that's a requirement for the mission to proceed, and they look like they're operating fine. So there again, we're pleased with that. The camera, for those of you who might have missed it, we did unlock the camera in this last set of activities. The camera is unlocked, it is functioning, and we're actually, as we speak, probably doing the sun search activity and beginning to take the first images. So hopefully in a few hours or a few minutes or less, we'll be getting those first images back. The lander temperatures are all within the predicted range, and basically, like I said, it's about as normal and about as straightforward, or essentially just what we estimate or just what we calculated if everything were going to go right. As far as the rover's concerned, we did get information from the rover. The rover and lander are communicating well. About 98% of the packets are getting through between the rover and the lander, which is excellent. The rover's awake. It was awakened by lander command. All of its engineering subsystems checked out. All of its temperatures are within the expected range. Solar arrays producing power. So we're basically, like I said, doing really well. And we, as you heard over the net there, activated our next sequence, and we're going to go ahead with the remainder of the surface mission. So with that, I'll let Rob talk about entry, descent, and landing.
Well, the little engine that could did. And we are just absolutely boggled by the fact that this fairly complex design that we've been thinking about and stewing over and testing and trying to make work really did the job. And you've seen me, and I've sort of been representing the entry, descent, landing team, but really this is a team that all Americans should be proud of because it involves so many people from all over this country of ours. It's from coast to coast. I wouldn't say every state in the union, but a lot of people from all over helped, all over NASA as well as JPL. So it's something that a lot of people can take credit in, and not just me. So with that, I want to let you give a little bit of interesting information about how it went. It turns out that there was a few surprises, not too many. One of the spacecraft landed almost exactly at the time we predicted it. The signals, as you remember, we had some interesting signals from the spacecraft after we landed. My worst case expectations did not come true. It turns out the spacecraft was very visible after all once it rolled to a stop. The spacecraft did in fact bounce as the spacecraft was designed to do. In fact, it bounced quite high. Maybe I've got actually an accelerometer plot here if you can If I can pull that one out, that's not the right one. Actually, that is a good one. That's not a bad one for the, there we go. There's a good one right there. Maybe you can pull that one up. You can see, I won't talk too much about the first one. You can see the little tiny spike. That's just an anomaly in how we change the gains of the accelerometers. But that big bump here, that's the deceleration of the vehicle as it went through the atmosphere. Soon thereafter, the software under an algorithm that uses the acceleration, the deceleration profile to figure out when to open the parachute. Open the parachute a little bit later than we expected, which is indicative of the atmosphere being a little bit thinner than we expected. We don't know how much. Not too much later, the rockets fired, giving a nice little boost to the vehicle, and then it hit the ground, and it hit the ground a few times. At least there's one bounce there. We think those are bounces. This data was just put together by Dave Gruhl here about literally 15 minutes ago. So we really haven't had much time to analyze it, but there's no question that the spacecraft hit the surface of Mars quite hard. We haven't looked at the orientation yet, but the first time it hit the surface of Mars was about 18 Gs. It bounced again about 15 meters high, we think, which is pretty high. About 50 feet, and then it hit again about 9 Gs of deceleration, and then it flew up again for another 7 meters in the air, and then hit even harder, 11 Gs. And we haven't figured out what that's all about yet, but it might be in the fact that the spacecraft actually spun up as it impacted, and that could fool the accelerometers into thinking it was actually a straight translation. So there's a couple other surprises, and that's it looks like our terminal descent velocity, that's the velocity that we sense with the radar, was about almost 10 meters per second faster. Instead of going about, let's see, I'm doing a metric conversion. Instead of going about 120 miles per hour, they're more like 140 miles per hour at the time the rockets fired, which is a little bit surprising to us. It means that we don't really understand the atmospheric density of Mars as well as we thought. But on the other hand, it was well within our expectations of how the design was, the design envelopes. So it was just a little surprise. It wasn't a big deal. The other thing is, this is the part that I lost this bet. This lander has 4 sides, as a tetrahedron should. But what's the odds of rolling down in the base pedal, huh? 1 in 4. I picked it was going to do this. This spacecraft rolled to a stop just like this. And we didn't have to open the pedals to right itself as we had designed it to do and tested so many times. So, if people ask, well, how do you right yourself? Well, we don't have to right ourselves. We didn't have to this time, and didn't need these pedals after all, Richard says. So the spacecraft appears to be, the airbag's fully retracted, and appears that the pedals are really open, perfectly flat. It's interesting, the software tells us that these things have happened and did not feel any errors or sense any errors during this process. So it's a very good bet that they really are. But we will get a better indication in the next downlink session when we actually take pictures around the periphery of the lander and see how the airbags are bunched around the vehicle. So that will be kind of the proof of the pudding, but I'm very happy, and I really am not out of a job. It turns out that I'll be working on surface operations with Richard for some time to come, but as far as the entry set landing job, we're there, and we couldn't be happier. Thank you. Sure. Thank you. Let's see. We have another picture of some of the temperatures on. Let's see. Not that one. The one we just had. No. One more. No. Actually, how about pull out the landing site picture? There's we've got several. First one. I think this is the very first picture we have here to show where we think we landed. Okay, go ahead. That's a good one. Why don't you go ahead and pull that up so people can see? Well, this is where we think we are, And it's interesting to note, our navigators, if you remember, put us in this region early this morning by 7 o'clock. It turned out that we ended up landing a little earlier in terms of, I say earlier, I mean a little bit less downrange of our landing site. Remember, we're coming in from the northeast, going in this direction, working our way past the center of our desired ellipse, and this is where we ended up. We thought we would be down here. Matt can tell you more about what we're going to see if we land in this, if we really are here. The reason this thing got so small, we're not sure why it moved just yet, but it appears that there may have been an atmospheric density differences than what we expected, as I mentioned before. That's one possibility. Maybe other reasons as well, but this information was acquired over DSS 65, is that right, Richard? Yes, and at the SPF, the station in Madrid, the Deep Space Station in Madrid, over a few hours before we went before we got into EDL. So I think we're safely there, and I'm going to let Dr. Tim Schofield talk a little bit about what we might get from a science point of view from this entry, descent, and landing data.
Okay, thanks, Rob. The first picture, thank you. The ASI MET is composed of two parts. One part of the experiment is to understand the structure of the atmosphere as we enter the atmosphere. The other part is basically a weather station on the surface of Mars. And we have now got the first data from the first part of that mission. This slide that's showing now shows you a detail of the acceleration curve that Rob showed you earlier. At time zero, we're at about 160 kilometers. We hurtle into the very tenuous upper atmosphere, and accelerations are building up gradually all the time. Finally, we hit the maximum deceleration peak here at about 15 G at about 120, 130 seconds, which is a height of 30 or 40 kilometers. If we could have the next slide, please. This is the same data, but plotted on a scale which shows our measurements from very high in the atmosphere. From here we have 10 millionths of a G acceleration, and building up all the way as it comes in, all the way up to that 15 G acceleration peak again. And then you have the parachute deployment pulse there. This information is going to let us work out the density profile of the atmosphere from basically all the way out high in the atmosphere down to well below the deceleration peak, down to where the parachute deploys. We then have pressure and temperature measurements below that level also. We have very preliminary data from the landed part of the mission. We haven't deployed our mast yet. It looks as if the temperatures that we're measuring are around 220 Kelvin, which is about minus 64 Fahrenheit. Those temperatures are somewhat warmer than Viking, but the mast is very close down to the spacecraft on the petal, so it may well be that the sensors are being heated by the sun rather more than they would be when they're up in their correct position. So we're looking forward in the next coming hours to getting the rest of this entry data set, much higher resolution, and working out the density profile and hopefully the pressure and temperature profile, and then getting the time series of atmospheric data. It looks as if both instruments have worked perfectly. Richard mentioned this being like a simulation. To my mind, it's nothing like the simulations. The simulations went wrong all the time. From the point of view of the scientists, the data was always getting lost and going wrong, but so far it's been going very, very smoothly.
Okay. You've heard the very first data we've gotten from our spacecraft, or first science data, I should say, and that will help the atmospheric scientists try to work out this entry, descent, and profile of what the atmosphere is like all the way from 120 kilometers down to the surface. I'd like to back up to about 3 a.m. this morning, and show you what we went through in the last few hours prior to entry. If I could have the first slide, please. What you see here is the landing ellipse. In the so-called science ellipse in this large yellow, and at about 9:30 last night and later at about 2 a.m. this morning, the ellipse was this white one shown here. which actually cuts through the northern half of this streamlined island. And some of us scientists were there at JPL at midnight to 2 a.m. trying to determine the slopes on this streamlined island to make sure that they were within the tolerances that the spacecraft could handle, to determine if we needed to do a trajectory correction maneuver to try to nudge us into a so-called safer region. And one nudge would have put us over in this region. Another could have put us up in here, which actually looked worse. One could have put us down here, which is definitely worse. And cooler heads prevailed, and we in fact did not do that trajectory correction maneuver. And we wound up landing right in this small piece of this ellipse shown here. And the next slide shows a high resolution, a detail of that. What's shown on this is the best prediction from the navigation team as to where we actually wound up on the surface of Mars. And it's somewhere within this ellipse, and you can choose your pixel, and that's the one we're in. We do not know which pixel we're in, and it may take us a while to figure it out. What also shows on this are the 20 pixel elements that should be visible from a portion within that circle of large hills like this one here. 20 pixels could be seen by the camera if we landed within that red circle. And there's a larger streamlined island to the south. Could we go back one slide just for a moment, please? Back to the one we were just showing. Thank you. This large streamlined island, this one right here, is about 500 meters high, we think, with what may be a boulder bar behind it. This should be visible in a much, much larger region, this red circle shown here. Back to the next one again, that's the circle you see here. And again, here's a small hill. Well, small, that's a building. Small hill with, again, that 20 pixel element that should be visible. Here's a crater that we should see. And so we're hopeful that after we turn on the imager and start taking pictures, which we've actually are doing, I guess, we will see some of these things. What you'll also notice are this series of what we call secondary craters. And if you look carefully at these craters, they have a bit of a herringbone pattern, which actually tells you the direction that the primary crater hit the surface of Mars. And this is ejecta from that primary crater that is now flopping across the surface. And those herringbones point to the south. We believe the primary crater for these secondary ejecta craters is about 60 to 100 kilometers, or that's one guess. And we might be somewhere in the midst of these as well. And there was some worry, of course, that this would be a very rocky area, since that there's quite a bit of ejecta around these craters. Interestingly also is that these craters seem to have captured some of the dark mafic material. If you look at the pictures of Mars that we've shown, there's sort of this reddish material, and then there's this dark black surface stuff. We think that's a dark mafic sand, and we may have the prospect of actually seeing some of that. All of which we don't know what we will see. Again, I don't know which pixel we're in, and we'll just have to wait and see. Okay, now what's next? Within the next half hour or so, 35 minutes, the meteorology mast, the 1 meter mast, will deploy into the upright configuration with the wind mast on top and the 3 temperature sensors, and we hope to get our first weather report from the surface of Mars at about 35 minutes from now. We should be, if we're very fortunate enough to get the high gain antenna, start receiving the very first images from the surface of Mars. And I want to walk you through what to expect when you see them, and warn.
All right, the timetable is set. The clock is ticking. 34 minutes from right now. It is very possible we could be seeing the first picture sent live from the surface of Mars in the past 20 years. And that's what the scientists are saying. We're going to go to Moneyline now, and we'll be back at about half past the next hour, or if the first pictures get here ahead of half past the next hour, we'll be back with those as well. John Holloman, CNN, reporting as our journey to the red planet continues.
first pictures back. Now, these are not very good-looking pictures. These are going to be little, highly compressed pictures, and that means that to send them back with not too much data, so they come back pretty fast, they're going to take a lot of the data out and just squeeze the rest of it together. So we don't have stuff it on the ground, but we do have a way of decompressing the pictures. But these first ones aren't going to look very good. What they're going to do, though, is tell us whether it's safe for the rover to get off or not.
That'll be and then you will get that panoramic view, that the one I guess that everyone is really waiting for, that look out over the Martian landscape.
That's right. The color panorama should come back around 6:30, something like that.
So it'd be about 9:30 Eastern time,
right,
folks on the East Coast, 6:30 Pacific time. And then the rover off the lander sometime later in the evening, perhaps an hour or 2 hours later at the most?
Maybe
not
yeah,
even?
at the most. Because once we know that it's okay, then we'll deploy the ramps, tell the rover to stand up, and if the ramps fit right, if everything's good with the ramps, then bang, we get the rover off, because we want that rover on the ground to spend the first night. We don't want her on the solar panels.
Donna, thank you so much. You've been here with us all day, and we still have quite a few hours, it looks like, left to go this evening before we're permanently chained here. So another milestone coming up in about a half an hour or so, that first image from Mars, what everyone will be waiting for. And then as we move on through the evening, Relitza, we will be, of course, getting the color pictures, the rover off the lander, and just an exciting time yet to come here from the Jet Propulsion Laboratory and from Mars, about 120 million miles away, right? Something like that. Yeah. Relitza?
Thanks, John. We can't wait to join you again for all that excitement. And elsewhere in space, Russia's mission control is giving the crew of Mir an extra 6 days to get ready for repairs on the space station. Russia's most famous cosmonaut, Sergei Krikalev, will be the chief advisor when the repair work begins in about 2 weeks. For now, Krikalev is leading training exercises at Russia's Star City, simulating the repair work underwater. A collision last week damaged the Spectre module and forced the crew to disconnect cables that link Mir's power system to solar batteries.
The following is CNN's coverage of a live event.
Welcome back. It's John Holloman at CNN Center. We're going to take you right now into the control room at the Jet Propulsion Laboratory's Mission Control in Pasadena, California, where everybody in that control room is gathered around a computer monitor. And as you can see, the people in there hugging, kissing, applauding, clapping. The reason they are doing that, we believe, is that the first picture to be seen on planet Earth live from the surface of planet Mars is beginning to appear in that control room. Now, okay, this is the live picture. You can see the excitement on people's faces.
You can hear the excited...
Let's listen to the commentator there.
As Pathfinder Mission Control, as they have been locking on the high-gain antenna, or right on schedule, 4:30 Pacific Daylight Time, and they have indications that the high-gain antenna has located the sun.
Well, this is good news. One of the things that had to happen...
Of course, is essential for transmission of data from the high-gain antenna.
Donna Shirley, you're the Mars Exploration Manager for NASA. Listen to this and comment when you like.
Okay. Well, what's happened is it looks like that the sun-finding algorithm, that is the equation that told the camera to find the sun, has indeed worked. The computer program on board the lander completely autonomously has found the sun, and then they were able to actually point the high-gain antenna, the lander, all by itself, at the Earth, and so we are now starting to get a signal from the high-gain antenna, which means that we will be getting the pictures back.
A lot of cheering and yelling and screaming and attaboy and attagirl going on in this room.
More handshakes and cheers.
We have 4 frames in lock so far.
I suspect that the pictures have started to come in.
Donna, there are a lot of computer monitors in that room, including 2 that we can't look directly into, where the shift leader is looking. Where will the first picture come in?
Well, I don't know which monitor the picture comes in on, but they're supposed to go up on NASA Select right away. So within some small period of time, we should be able to pull them off of the NASA Select feed.
Okay, we have an internet site here that plugs in to the Jet Propulsion Lab, and I believe the pictures are coming in on that internet site right now. We'll check that and pop it up, and we may get it as quickly as the folks at NASA Select get it. We'll find out. And
now, what these?
Go ahead,
let me
Donna.
explain what these pictures will be of. If you can get down on our little model here, where these pictures will be of the edges of the solar arrays to make sure that the airbags are neatly tucked in under the solar arrays and that they're not lopping over onto the pedals and blocking the pedals. And we're particularly interested in the pedal that the rover is on because we need to be able to deploy the ramps off the edges of the solar panel so that the rover can crawl off on the ramps and get down onto the surface. And that's the next big event after the pictures coming in. Now, these pictures that we're getting are just little black and white images, very highly compressed, just of ugly little airbags and possibly the rover's wheels, and the rover's part of the rover and part of the ramps that are going to unfold for the rover to get down. So these are not going to be very pretty. The pretty pictures are going to come in at about 6:30. Oops, I bet you a picture just came in.
That's probably an image right there.
Yeah, there it is. There it is. That is an image. Okay. Oh my gosh, it's beautiful.
What is it?
Okay, well, we can see a little bit of Mars. There's rocks. There's the airbags just sticking up just a little bit. They look just fine. So we've got Mars. We've got rocks on Mars. And boy, is
that a rover wheel? Was that?
Yeah, that was the rover wheel there a minute ago. Now, I can't tell what this is. Boy, these are hard to see on this little bitty screen here.
Donna, CNN is going to try eventually to get a bigger TV.
That's a solar panel there, John.
See the solar arrays on it? You can see that, and this must be, look at those airbags. They're just beautiful. They're all tucked in very neatly. They're not on top of the pedals at all.
Which really means you're in excellent position to get the rover off.
Excellent position to get the rover off. Now there'll be some more coming in because what they want to do is to take pictures all around the edges of the pedals to make sure that there's no interference.
Will they put them together then in a mosaic, so to speak?
Yes, they will, but they probably won't even bother to mosaic these pictures because what they're going to do is wait for the color pictures to come down. Now that they know the high-gain antenna is correctly pointed, the next images that come down will be the color images, and then they're going to make a really beautiful mosaic that'll have color, that'll have the rover in it. The rover will be right there in the middle of the picture, and
now this is, you know, we should be pretty excited. These are the first pictures in 21 odd years from the surface of Mars.
Absolutely, absolutely.
This is a tremendous event unfolding right here now.
And there's rocks right there, so the rover won't even have to go very far to find rocks. I mean, this is just, it's beautiful.
It barely has to go off the limb and get to work with the pedal with the alpha spectrometer, proton X-ray proton spectrometer.
Alpha proton X-ray spectrometer. Very good.
And doesn't have to move very far. Yes, John.
Let me just jump in. These pictures are coming in very rapid succession, it looks to me like. Is that an indication that the high-gain antenna is doing precisely what it's supposed to be? I mean, I've seen 7 different views show up on this computer screen just in the past few minutes while we've been talking.
Absolutely. This means the high-gain antenna is not only pointed at the Earth.
There's a good wider photo.
Oh, wow. That's hard to see, though. Oh, here it goes. This is one of the pedal actuators that you can see here. One of the motors that actually opens the pedal up like that.
Wayne, can you...
Does it look good to you, Donna?
Hard to see. It looks beautiful to me.
Now, John, is the vehicle taking, this is all pre-programmed to take these? You haven't commanded it to do any of this.
We haven't said a word to the vehicle yet. These are all pre-programmed, and there's going to be something like, I forget how many of these, but they're 80-to-1 compression. So if these are this good, you can imagine what the real pictures, when they get in color and full and not compressed, are going to look like.
Compare these, just from what we're looking at, to the Viking pictures.
Right.
I mean, these are probably better than the Viking pictures.
Well, not yet, but they sure will be. They'll be a lot better. Now, see, this here is showing where these pictures are being taken. This little pie chart.
Yes.
It's showing where the pictures are actually being taken with respect to the lander, so that you can see. Now, here's some. Oh, wow! Here's some close-ups. So, and see the airbags. There's a little bit of airbag sticking out.
That's
only a little bit.
On the right side of the screen, John. That's the airbag and the wheel, and on the left side.
Airbag over here.
And what they're trying to do now,
a little airbag.
Yeah, Donna and John, they're trying to begin to mosaic these pictures together. Those
they
two
are gonna
pictures,
mosaic these.
yeah, they appear
Okay,
to be
great.
together at this point. So the picture
Oh,
that we're
yes,
getting is
okay.
bigger and bigger and bigger, and
Okay, very good.
more and more fascinating. Donna, I don't know how well you can see on that tiny little TV set where you are.
Not well.
Yeah.
Not well.
On the left side of the two pictures, there appears to be a little black blob sort of in the center of that picture. Just
This here.
Yeah. Now,
Yeah.
is that a normal-looking thing to you?
Actually, I'm not sure what that is, but it's too regular to be abnormal.
I see. Okay.
It's probably just, oh, I know what it is. When the panels are latched together,
Yeah.
they come together, and if we can look down at our little model, and we can't, it doesn't do you any good. We can't see it. Anyway, when the panels are folded up, they're latched together, and that's one of the latches. And how you release that latch is you fire a pyrotechnic device that pulls the pin out, and then the rover pedals can come apart, and that's what that is.
Yep. This is amazing. I mean,
And look at those rocks. Look at those rocks.
John,
There's
up
rocks
on the,
right
up-
there.
the upper left of that picture on your left, Donna's referring to those rocks that are right off of the pedal.
Yep, I can see them out there. Yeah, we have
I'm having trouble telling what the thing on the right is.
On the right-hand side, is that the
this is.
rover wheel that
I don't
we're looking
think so.
at?
It
No.
doesn't look like it.
No.
It's really hard to tell from this tiny little monitor.
Well, we're going to get more
But it appears
pictures.
to be rocks.
We're going to get more pictures. Oh, yeah.
That's right. And as we get more, Donna, I was going to ask you before we went into a news conference a little while ago, if this were an ideal world and everything worked exactly the way it was supposed to, how many pictures would we see from the surface of Mars over the next 7 days?
Oh, lousy. Lots and lots. I don't know.
Hundreds and
I don't know
hundreds.
how to count them. Hundreds and hundreds. That's right. And now they'll be taking pictures of different objects. So first they'll do a complete scan of the horizon with all 12 different colors.
Yeah.
This camera takes pictures in stereo in 12 different colors.
And the people back at your end are wearing 3D glasses, some of them, to get
That's right.
the depth and all on these.
That's because these pictures are coming in stereo.
Could our viewers do the same thing? If they watch these pictures at home, if they had 3D glasses on, could they see some of the relief in the pictures?
No. No, these pictures have to be very carefully processed, and it's a very special, very high technology silicon graphics computer that makes them into 3D.
Okay.
And you have to have very special glasses to see it.
There's a new photo up there
Yeah,
now,
here's
John.
one.
It looks like, is that airbags?
Yeah, that's airbags around the edge.
Around the
Okay,
edge.
now this is of the edge, and see the airbags are tucked in close to the pedal, and there's another rock right there, and that's a light rock. So we've so far got dark rocks and light rocks, which is exactly
What you wanted.
we wanted. Now, I don't know if these are really dark and really light because we won't be able to tell until we get the... Oh, wow,
There you
there's
go.
a real close-up. Okay.
Yeah,
See, this is the edge of the pedal, and it looks just fine to me.
Look tells me that we have not taken any faults since our last demonstration.
Little mission commentary in the background there as the folks in the control room with that computer are talking about these pictures. We can hear a lot of background noise there, and we'll continue to listen up as we hear what these people have to say.
If they're making commentary, it's better than my commentary because they can see the pictures better.
Yes, all of the relays are in the correct position. The battery state of charges is 72.8%. Shunt current is 1.35 amps. Bus current high is 3.25. Bus current low is 3.33. The battery is charging at 0.12 amps. The battery is discharge is 0. Pedal solar array current is 3.37. The bus voltage is 28.8. The battery voltage is 28.96.
Perfect.
The battery temperatures are 18.87 and 19.55. So
All of
everything
these
relative to the
numbers are
power
just
system
perfect.
is nominal. The battery is at a
Everything
higher
is totally
state of
nominal.
charge.
Great. That means all the power system is working right.
Slide ATS.
Go ahead, ATS.
The quaternion
Oh, here's Planet Fest.
This is an interesting sight. People here are watching at the Planet Fest in Pasadena, California, and there's a huge crowd there. Hundreds and hundreds of people are interested in planetary exploration. They are looking at these pictures on a big screen TV, and they just seem to be fascinated. They're not cheering like the mission scientists are, but they are certainly enraptured by what they're seeing on the surface of Mars, as are we all.
John, there are about 2,000 people there, and I don't know if you heard Donna before. She was saying that all of that data that they were reporting is just says that
vehicle is performing perfectly. The batteries are in perfect condition. Everything is in excellent shape.
Yeah,
Temperatures are right on.
Temperature is a big thing on Mars, Donna, because it varies so dramatically from middle of the day to the middle of the night, right?
Yes, somebody told us that it was actually only minus 64 degrees Fahrenheit, which is quite warm for that time of the night. I mean, remember, it's dawn now, and the sun is starting to come up and warm things up. Wow, now that is, what is that? That's an airbag with dirt. Okay, good dirt. So Henry Moore will be very happy. He likes dirt.
Geologists love dirt.
Yeah.
And this is mostly a geology mission, right, Don? I mean, the pictures are fabulous for us, but the folks who are really going to be able to get a lot from this are geologists who are going to look at these various rocks as the rover goes around and points its looker at these various samples that are there on the surface of Mars.
It's actually more like a sniffer.
Yeah.
And so as well as looking, it's going to sniff them. And so we'll not only know what they look like, but what the chemistry of them is.
Little chemistry set in space.
Oh.
It's just amazing.
Okay, now there's another actuator. So all this stuff is showing that everything is just perfect. I mean, it looks like that model in the auditorium.
No kidding. There are a couple of the wheels. This is what happens, when they open the cargo bay on the space shuttle. They do a survey.
These are the rocker bogies. Okay. What we're seeing here is this must be the back of the, now that's a solar panel. Oh, there's a wheel. See that circular shiny thing there up in the upper right corner?
We had seen one just a minute ago as well.
Yeah, we've seen at least the 3 wheels on one side, Donna, go by.
Okay, now this is some airbags. Okay, this is in between the pedals here. I can't really tell what these look like.
This is Mars Pathfinder Mission Control.
I can't tell what that particular...
Oh, look at that, Donna. That's looking out from the rover.
Okay, all right. Rocks, lots of rocks. Beautiful.
Looks kind of like Mars.
Oh, there's a big rock. There's a big rock.
Yep. Right up at the upper right-hand corner of your screen.
Yeah. Oh, boy, is the rover going to love to get its spectrometer on that one.
Yeah.
Woo.
Folks at Planet Fest are up on their feet now. It's like the World Series out there. Up and applauding.
Oh, this is incredible. Just look at that. It's an easy trek over to that rock, an easy trek. So we can send the rover right over there. And the rover can put a spectrometer on that rock anywhere.
That's a nice picture, too. A nice wide picture.
Oh, yeah. Oh, look, there's a big, those are big rocks. Those are lovely. Now, see, this is the advantage of the airbag. Because if we landed with propulsion the way that Pathfinder had, we wouldn't have been stood off from the rocks like this. We could have been right on top of them. But the airbags have stood us off from the rocks. And so those airbags have done their job.
And also, if you were using a rocket to get you down there, a lot of what was on the surface would be blown away by the rocket blast, right? I mean, this is pretty much undisturbed.
That's true, except for where the airbags have actually dragged in. But that's actually good because that turns rocks over, and we'd like for the rover to be able to put its spectrometer against the unweathered side of the rock. So we'd like to turn rocks over. So if the airbags have turned a few rocks over, we're going to be very happy. Although we don't expect to find any worms under them.
Donna, I can't tell if you have just planned this so very well so that everything that happens is just exactly the way you want it, or if it's just a very lucky night for you and your Pathfinder team. I think it's probably the former.
Well, a lot of it's the former, but a lot of it has to be the latter because we don't know what Mars is like. I mean, we were diving into an unknown terrain. It's like if you were going to Acapulco, those divers that dive off the rock?
The pearl divers,
and they've done it before, so they know where they're going. But if you went up the first time and you didn't know, you'd probably kill yourself, right?
Yeah,
so this is just like diving in where we don't know diving into the pool where we don't know what's under there. And so there's a lot of luck to it that we have as well as just superb engineering and science. Now there's the rover. Okay, this is the solar panel of the rover. And you see on the top edge, there's a close-up now, that bent part that's got a double bend, that's the antenna.
Yeah.
So that means the antenna's locked in properly, the solar arrays look good, there's rocks right there, everything is looking terrific.
That was looking down right on top of
right
Sojourner.
on top of Sojourner, that's right. Now she hasn't stood up yet, so when she stands up, then it'll be somewhat different view.
Donna,
and this is
approximately when will Sojourner stand up, and how does that work?
Okay, as soon as these pictures are in, if the scientists put them together and determine, and the engineers, and determine that it's safe, there's some airbag stuff all folded up, and I don't know where that is. So I don't know if this is a problem or not. But if they determine that the airbags are in good condition, then they'll right away send the command, to deploy the meteorology mast, and for the rover to stand up, and for the ramps to deploy. Then, after they deploy the ramps and the rover stands up, they'll take another picture. That's when they get this really nice color panorama.
Yeah.
That is what they'll make the decision to send the rover off or not.
Now, how long do you anticipate it to take for all of these postage stamp-sized pictures, as others have described them, to come in? I mean, how long before they have the mosaic ready to show us?
Well, I really don't know. I think it will probably be another few minutes.
But we're getting to see these things absolutely the first, just as they come out on the computer.
Absolutely. We promised that to the world. We said as soon as we get these pictures, everybody's going to get to see them just as soon as we do. And this is really unprecedented because always before, the scientists had rights to the data, so they could hold the data for a long time until they felt comfortable releasing it. And Peter Smith has taken the risk of just putting it out there without knowing what it was going to look like, and that's quite courageous for a scientist.
All right. Well, listen, Donna, we've got a picture now of your crew in Mission Control doing the same thing our viewers are doing all over the world now, looking at the TV set as these pictures come in. Our viewers actually have a slight advantage over the people in the control room in that we can take the little pictures and blow them up to fill the entire TV screen. It's a pity you don't have a big TV screen like I do. But
well, all I have is this scrunchy little monitor. Oop, there's some rocks. Okay, now, see this rock? It's all pebbly looking. Now, the Viking images had rocks that looked much like that as well.
Yeah.
But then there's a rock beyond. I'm not a scientist, and so I'm just blithering here, but the rock beyond doesn't look to me like it's as rough. And what we want in this landing site is to have all kinds of different rocks. And I bet you we're going to get them.
Sand looks as if it's almost wind-blown there.
Right, it probably is. In fact, that looks like a little dust drift to me.
Right.
But again, we're not scientists, so I'll defer and let the scientists talk about what it really is.
Well, it is a fascinating picture, Donna. I'm looking at it as closely as I can here, and it looks sort of like a lava rock, like you might have in your garden, or if you went to Hawaii or someplace. Here's another picture. I think probably the other side of the same rock.
Yeah, that's the other side of that same rock.
Yeah. And it looks almost spongy. I don't know if that's what you said or not, but it appears to be lying on a beach with very fine powdery sand in this black and white view.
Right. Well, actually, that's what the Viking 1 site looked like, and the Viking 2 site as well, is they had rocks like that with wind-blown sand that had blown up against them. And so, at least to first order, this doesn't look all that different than Viking, except the rock on the right looks to me lighter than the rock on the left.
How far away is this landing site, roughly, from the Viking landing site?
It's well over 1,000 kilometers. So it's really a long way away as planetary distances go. And we expect the terrain to be quite a bit different. We don't think that the Viking landing site, that's Viking 1, was in this river valley.
Now, Donna, you say in this...
It's mostly crater.
Yeah, in this river valley. Any idea how long ago it was that a river was flowing down through this area of rocks here?
No, and that's, okay, there's, I don't know what that is. We really don't know. The best we can do is say that by age dating, that means by counting the number of craters. If there's fewer craters, that looks like a hole to me. It looks like something has been...
A depression, kind of, yeah.
A depression. Now, maybe that's where the airbags dragged a rock out. That could be. That's just a guess on my part.
Well.
There it is. I lost my train of thought. What were we talking about?
That's what we're seeing in the picture.
The age of the river.
The only way you can tell how old things is on Mars, because we don't have a piece back yet to age date. Okay, now this is a calibration target. See that circle? And so that's going to help the camera calibrate its color. And so that's why we're going to get the color to be right on those first color pictures.
Sort of like in TV. We point our camera at something white and push a button and it gets all the other colors right.
Right, and this is sort of the same sort of thing. Now, the age of the river valley that we're in is not... Wow!
Look at it.
Look at that. Oh, that's great. Oh, look at all those rocks.
Looks like Arizona to me.
Sojourner's going to have a field day. This is just beautiful.
What is that?
Oh, look at that. There's a flat top rock.
Flat top rock.
Wow.
This is amazing.
This is amazing.
Now, Donna, this looks like a piece of airbag over here.
Yep.
That's all
that's That's what they're really trying to do, is take pictures of airbags, but every now and then they goof up and get a really nice rock picture.
Wasn't that spectacular? I mean, it really did. It looked like Arizona with little tumbleweeds and things. Obviously not tumbleweeds, but ooh, look at
Right.
this.
There's another one. Oh, wow.
There's something.
gee
See
whiz.
that rock? That looks like a big one.
Oh, my gosh.
Another
That's
one
a
here,
big one.
and a
Now,
three
see,
or four
there's your
here.
airbags. Airbags save this.
Yeah.
If we tried to land propulsively in this area, we would have been creamed.
Apparently we were not creamed.
Nope, Tom Rivellini and his crew really did their job. And ILC Dover, I should mention that ILC Dover was the contractor that built the airbags for us.
When I talked to Tom Rivellini this afternoon, he had said to me, he says, I wasn't worried about the airbags. I was worried about everybody else's systems. I knew they'd work, he said. And they did.
Yep, they did. Really remarkable. They were the thing that was making everybody nervous. You know, everybody call in and say, oh, those airbags, they're not dangerous. But it looks to me like they just worked perfectly.
The landscape shot shows some
Well, the pictures keep on coming. This is, boy, you know, I'm going to be able to tell my 4-year-old that I was here on this night. Look at this flat rock here.
Wow.
Isn't that interesting?
Huge rock.
It went
Flat
away.
rock. Oh, my gosh.
I don't know if this is a rock or an airbag, this
Rock.
piece here.
Oh, you know, gosh, that's just, I don't know, that's airbag.
Yeah.
That's airbag.
But that quick picture of the flat rock, it looked like sandstone almost.
It was incredible.
weathered on the
Now,
top.
we know that what happened was that these rocks got dragged downstream, and so it could be that they got dragged so hard that it abraded the top of them off, or it could be that they were actually from a flat part of the terrain and were kind of floated down, and so we just don't know. Boy, are the scientists going to have fun with
I was
this.
going to say, this area is going to be a
There's gonna
field day,
be,
isn't
yes,
it?
there are going to be happy, happy, happy scientists.
And it'll take years to figure out what all this means, right, Donna?
Yes,
I mean,
yes,
they'll be
it
looking
will.
at this, and people will do their doctoral theses on things like this.
For years and years. Now, we have actually, with the Viking data, they spent 20 years analyzing it. And we can spend 20 years analyzing this data, too.
Whoa,
You
look
can
at this.
rewrite everything.
Look at this, you guys.
Oh,
Does that look like a hill or
wow.
what
See,
is
there's that flat rock again.
it almost looked like the contour
Yeah.
of the land was going up.
Well, that's what they thought they might actually be able to see, is, you know,
rise
something in
in
the
the
rise in the
distance.
distance, yeah. Now, that looks like a wheel. Oh, no, I think that's the APX. I think that's the spectrometer on the back of the rover, but I'm not sure.
Oh, that's the sniffer. No, there's a wheel. You can see
Yeah, there's a wheel. Okay.
the central area
Looking
in
good.
that.
There's no airbags on top of anything. You know, the wheels look really good. I can't see the restraints.
They're cheering.
We're getting cheers. Is that cheers from Mission Control or cheers from...
From the Planet Fest. I can't tell. We're hearing
Okay.
things from all over right now.
Oh, wow. There's Sojourner. Look, you can see the little teeth on the wheel. And
Yeah.
the rocker bogies are looking good there. Yeah, that's the little teeth. That's what somebody's pointing out.
Yeah, I'm working the little illustrator
with his
back
Oh,
there.
that's John. Okay, okay. And then the rocker bogie is that thing full of holes. Okay, there's another one.
Yeah, all
Boy, I
right.
wish we had better light.
Coming soon.
That's the wheel again.
Yeah. That's the wheel again. You're right. With the axle, the shiny part with the axle.
There's two wheels, Donna. There's one visible there and one visible there.
Yep. Looking good.
Same picture
Now,
again, I think.
When the rover gets off, then we'll be able to take similar pictures of the lander from the rover, which will really be cool.
We're currently seeing...
Okay, there's some of the tracks. That long skinny thing is the tracks.
Oh, that's the
rover
kind of the
sitting
red
out.
carpet that that will roll
Right.
out for it. Yeah.
Well, I do not believe they have unrolled the ramps yet, and
No.
I can't really spot the ramp.
Well, they wouldn't do that until they were sure that the bags were out of the way, correct?
That's right.
Yeah.
That's
Donna,
right.
what are
So
these things?
pictures-
Look like dominoes. Can you tell me? Here's there on the
You
edge
know,
of the airbag.
I can't tell you.
Okay.
I don't know what those are.
Hope they're from Earth.
Oh, yeah, they are. I'll guarantee. Okay, now there's nothing for Earth. That's from Mars, and there's a long... Wow. Boy, I wish I could see these better. Would you guys get better monitors, please?
Yeah. With all the money we're making on this, Donna Shirley, we'll get you a big TV for the
All right,
future.
get me a big TV. Yeah, I want a great big monitor.
There's
Okay, now
there's
what
some
is
more of
that?
these domino-looking
Yeah.
things.
Okay, well that must be part of the structure. I don't know what I don't know what it is.
Yeah. When it's put all together with the rest
See,
of them, I'm sure
and I
we'll
don't know what those spoke-looking things going on out
These.
here because I can't quite see. You know, I don't know the perspective.
Yeah.
Yeah, I don't know what those are.
Okay. As the pictures continue to come in, Donna, we're going to take a quick local cable break, and we'll be back at the top of the hour with more of this. What What a night. We are seeing history being made, ladies and gentlemen, from the surface of planet Mars, live pictures being beamed back to Earth. Pretty soon they'll be put together in one big old beautiful panoramic view of the planet. And we'll be here to bring the whole thing to you as the evening continues. Stay with CNN.
Looks like the journey is over. I'm Leon Harris here at the CNN Center in Atlanta.
It's a pretty exciting day here today. I'm Joey Chen. It started with a bounce, a roll, and a great whoop of excitement. John Holloman has been following up all the activities here today as we've been following what the Pathfinder's finding on Mars.
It's historic.
I mean, we need to bring our viewers up to speed here, so I will read a few words. Shortly after landing, the Pathfinder started sending radio signals back to Earth, letting its handlers know the lander was okay. And then about 30 minutes ago, we started getting these pictures. They're being beamed down as fast as the Pathfinder can send them back down to planet Earth. These are rock formations near the planet Mars. And this picture is just coming down. We've seen a picture similar to that in the past few minutes. The folks at the Jet Propulsion Laboratory describe these pictures as being postage stamp size. We are lucky at CNN. We have a machine that will blow up a postage stamp to fill your TV screen, and that's what we're doing with these things as they come in. What will happen over the next 30, 40 minutes is all of these small pictures will be stitched together electronically, and then, look at that. Isn't that something? That's a Mars view, and if you look up in the upper left-hand corner, sort of on the horizon, there's a hill. That's going to help them orient which way the Pathfinder is pointed, because they, on the earlier big, wide pictures of Mars, they were able to see things like that hill.
So they did identify that particular hill?
They haven't yet, but they will be able to, almost certainly.
Now, John, does the Pathfinder look for the pictures in any particular order? It just swings around and takes arbitrary angles?
The thing that these pictures are being taken for has very little to do with looking at the surface of Mars. It has to do with making sure everything on Pathfinder is working. It's mostly to check the airbags, to make sure they've deflated and gotten out of the way, and to check the various pieces of Pathfinder, the wheels. There's a series of devices that cause it to raise up off of the point where it's sitting, and just occasionally what they will do is send down these fabulous pictures of the Martian surface. That's going to tell them where to send Pathfinder. Right above the word news on your screen right now is a flat rock. Why is a rock on Mars flat? Scientists are going to be worried about that for a while. There are a couple more that are somewhat flat. And you can see out here in this area, there's a whole bunch of very large rocks.
Good-sized boulders.
Pretty good-sized boulders, based on where the camera is and the kinds of things it is able to see.
Now, do you know how many of these postage stamps they need to put together one picture?
A couple, I think it's about 100, and they have sent in almost 100. So what they're going to do with them is take them, get them together, make them into a mosaic, sort of like a mural put together from a bunch of little small paintings. And it's a little bit of a jigsaw puzzle, but as soon as the puzzle is together, we will see actually two separate pictures from this. The first picture will be a narrow-angle view looking just down at the rover, the Sojourner. And the second picture will be this bigger panoramic picture, the suck-in-your-breath picture. And we've been seeing the little pictures of that, like this piece right here. Lower left of your screen is a piece of the airbag. And so they can say, well, that's an airbag picture. And then you see this. These are being apparently sent back in different wavelengths. It looks like the same picture in different lighting, but it's just based on how they're taking the picture.
Well, now, this may be the first wave of photos, but have you heard any gasps of surprise yet?
I have, from among other people, Donna Shirley, who's the head of the Mars Exploration Program for NASA. Donna, you and John Zarella are just looking at these as I am, and Leon and Joey, and our millions of viewers around the world right now. Gasps of surprise. What's the most surprising or most exciting thing you have seen so far in this picture show?
The most exciting thing is the stuff on the horizon. Viking was and both Vikings were landed deliberately in a very boring place so that it would be flat and safe.
And, there it is right there. It looks like hills in the distance.
Yeah, and the hills in the distance, Viking couldn't see anything like this. And in fact, we saw one that's obviously a hill on the other side of the horizon. So this is extremely exciting because this is actual topography that's nothing like Viking saw. and in fact is much more like the Channel Scablands in eastern Washington that are the analog for this. And that will help us learn about what happened at this place.
You can see in the corner of almost every picture, John, almost in the corner of every picture, you can see the outline of a hill or a mountain in the distance.
Right, really
fabulous.
Spectacular.
Yeah, it looks kind of like Arizona, New Mexico, something like that to me. But when you did your analysis, you thought eastern Washington is what you'd be seeing, huh?
Well, eastern Washington is where these giant floods happened 13,000 years ago, and they ripped rocks out and carried them downstream and left these islands, like we saw in when the pictures we were looking down on the landing site. Remember, we saw those stream-shaped features? Those are islands, and they stick up. And I think what we must be seeing is some of those islands, because where we landed, we know from the last press conference that those red circles in the picture where you're looking down at the landing ellipse, those circles showed features that we should be able to see sticking up above the horizon. And sure enough, we're seeing features.
Yeah, let me ask you quickly, if I can, about that landing ellipse. Folks who might be just joining us this particular hour. How close did Pathfinder come to actually hitting exactly ground zero where they were aiming at?
Well, certainly within a few tens of kilometers.
Well, they had already said this was a hole-in-one where you landed. It was like hitting a golf ball at JPL and putting it in the cup in Houston.
Right.
So
only you get four. You get 4 strokes. And so it was a birdie.
That ain't too bad. That ain't too bad.
Not too bad. It was perfect.
No.
I mean, everything has been perfect about this mission.
Now, Donna, there are people now in your control center at JPL looking at these pictures with 3D glasses.
Right, that's Brian Cooper. He's the rover driver.
Yep. Okay. Now, what is he seeing in 3D that we can't see on television?
Okay, what he's seeing is three-dimensional. Those goggles he has on are 3D goggles. And he is seeing these first pictures, and he's trying to figure out whether the airbags are nice and flat and tucked in or whether they're sticking up. And when we just look at that with our bare eyes with a regular monoscopic television set, it's very difficult to get scale. With these 3D goggles, he can actually see the scale, and he's going to determine whether it's safe or not to deploy the rover ramps. That's his job at this point.
And John, he was telling me the other day that he will be able to place his mouse and click on the mouse, move the rover where he wants it to go, and then the rover will go there.
That's right. What he does is actually, in order to direct the rover where to go, his mouse can leave lawn darts. He leaves little icons of lawn darts. So he puts lawn darts where he wants the rover to go, and he based on the rover icon. So he's got all kinds of tricks he can do with that workstation. Brian, incidentally, wrote all the software for that workstation. He's the guy who programmed the workstation.
It sounds like he's got great mobility on this thing when he is able to start moving it. I mean, what will he direct it toward? Are you aiming at a specific target, specific things that you want to see?
The scientists are going to be going bananas because there's so many targets. They're going to be, clawing and scratching and fighting each other to choose the target. Actually, they're not. They'll be very civilized. But there were so many fascinating targets in there that scientists have different areas of interest. Like, say, some are interested in sediments, and some are interested in volcanoes ejecta, and some are interested in crater ejecta. And so they're going to be arguing about which rock to send the rover to.
John,
they decide.
Yeah. There are people all over the country and all over the world who are watching this. The National Space Society has taken over the Planet Hollywood nightclub restaurant in Washington, D.C. There are big screens there. Karen Rugg is there by one of those big screens, and it has a pretty big crowd. Karen, thank you for joining us. It's nice to see you. What's the atmosphere like that? Is it just wild and crazy?
Well, it's wild and crazy right now, John. We've got a restaurant filled with people. Some of them knew what was happening today. A lot of them were really thankful we put the images up here at the restaurant. I've been talking with couples from all over the world, and they're sitting there going, this is the neatest thing, and every time someone there says wow, they say wow also. But we're happy that we could bring the images here tonight.
Right, looks like a very big crowd and an excited and interested crowd. I've been to Planet Hollywood in Washington, and usually people are in their own booths doing their own thing with liquid refreshment, but people seem to be up and around and looking at stuff behind you there.
Yeah, the people, when the first images came up, and we've got at least 15 very large screens here, and when the first images came up in the bar, everyone stopped drinking and they were taking pictures of the images on the screen in the bar. And, you know, people are stopping eating and watching and asking questions of the National Space Society people we have located here throughout the restaurant. More of them are going to come here later tonight. We didn't expect everything to go as smoothly as it did today, as we found out. So we're still waiting for some people to arrive before the fireworks go off here in Washington.
Yeah, and the fireworks show in D.C. is about an hour away now. But we're going to go back, Karen, and let you and the people at Planet Hollywood look at these pictures as they come in from Mars. We've got a couple of different things that are going on. The rover driver is apparently sort of plotting his rover on the computer screen as he looks around at the first images to come in and gets ready to drive the rover off of the Pathfinder lander. Yeah, he's looking at the ramp that the rover will be traveling down. And from here, at least, the ramp looks pretty good. I couldn't tell if that was a simulation or the ramp is beginning to roll out. Donna Shirley, do you know at this point?
Well, when the ramps roll out, they roll fast.
Yeah.
It's not a beginning. They just go kerplunk. They're just like the children's toys, the party toys that you have at New Year's. You blow on them, and it goes zoop. And except they don't operate with air. They operate because they're spring steel. And once you release them, then they just unroll all by themselves.
Now, let me ask you something.
With, yeah,
I'm sorry, Donna. This is Leon back in Atlanta. I heard you earlier talking about this picture we're seeing right now. You were saying something about this picture being used to calibrate the cameras for the color. Is that correct? Now, now, can you tell us a little bit more about that and when we can expect to see some color pictures coming back?
You're going to be seeing the color pictures at about 6:30. The way everything is going, they should be coming back just about at 6:30, which is when we expect them.
Hour and a half from now.
Yeah, okay. We're going to take a quick break. The pictures continue to come in from the surface of planet Mars. The experts are there, and people are looking at them from all over. We'll take a little break. We'll come right back and show some more. Quite a night. All right. Stay with us. How about this? Our journey to the red planet, which we gave maybe 50-50 odds of being a success, is a big success. It continues. We're going to go around the country, go around the world, get reaction to this. This is mission control for the Pathfinder project in Pasadena, California, where they're now beginning to mosaic the various pictures together. This is a picture from the Planet Fest in Pasadena, California, where there's a crowd of about 600-800 people who are looking at the pictures coming in from Mission Control just across town at the Jet Propulsion Laboratory. We also have big screen TVs arrayed at other spots around the United States. There's one in Washington, D.C., where Karen Rugg of the National Space Society is standing by with reaction from her location. Karen, there were a lot of these pictures that came in. What did you think as you saw the first one and some of those terrific panoramic shots of Mars?
We thought it was absolutely tremendous. I mean, the quality and the resolution of the images, and as everyone there was commenting on the types of rocks that we were seeing and the types of material around those rocks, everyone here was asking, what are we looking at? What are we looking at? And especially also when we saw the airbags deployed. I mean, it's so exciting. And the fact that they came in so quickly and there were so many of them. I mean, what a change from 20 years ago.
No kidding. Remember the first Viking pictures? They kind of unscrolled line by line by line across the TV screen, and it was kind of funky. You had to, it was like a slow-speed computer versus high-speed computer, you know?
We have our online manager here, and he has his computer hooked up to an ISDN line here in the restaurant, and he's down in a corner. We're going to meet him a little bit later, and he's got some of the images up at the same time, and he's surfing the web and taking a look at what's there. Got people looking over his shoulder, and they want to know what's going on. They want to know more about the mission. So there's a lot of information exchanging going on here. We're going to try to beat the celebrations we saw earlier at Mission Control, but we're not sure if we can do that.
Karen, good luck. You have to do a lot of hugging and squeezing if you're going to do what they were doing in Mission Control
definitely.
at JPL. Okay, John Zarella, Donna Shirley are standing by in Pasadena, where it's still a beautiful sunny day. I hope it's gotten a little cooler for you guys. It was really hot there, middle of the day.
We moved under the shade. I've got to tell you, John, that they're doing a tremendously brisk business here right now, selling souvenirs, T-shirts, and this is the hottest item anywhere in town right now. It's a Hot Wheels that took about 4 or 5 months to design, and your design engineers worked on this. And
hold it up a little higher, John.
amazing.
Let's see if we can get
there
close
you go.
to it.
You can see it there.
Still,
I'll hold it. I'm shaking. I'm so nervous with how exciting the day has been so far. But it's tip it down. Tip it down. There you go. You can see it's got a lander, and it's got the rover, and it's got the back shell. And they can't keep these in stock here in Pasadena. They've gone through thousands and thousands of them, and I understand that there's a limited edition one made in like silver coming out in them.
It's gold, actually, 24 karat gold plated on a silver base.
I've been
You just
looking.
can't keep them in stock.
Yeah, I've been looking for this particular item for about 3 weeks, ever since I knew that all of us were going to be working together. I went to
What's
every...
it worth to you, John?
We'll negotiate off the air, John, you know? Jay Holloman has a birthday coming up in about 5 days, and we need to talk.
Well, now that Pathfinder has worked, these things are really going to be popular. They ain't seen nothing yet.
Yeah.
John, you know, one of the amazing things that Don and I watching these pictures, the really fascinating thing of these hills and mountains in the distance, that's just unbelievable.
Yeah, oh, it's just spectacular.
Hey, Donna, let me interrupt you. Look at the TV set over there, and this is
that's Brian.
That's Brian. It looks to me like the ramps are out. If
No, this is a simulation.
Right now,
and this is showing what it will look like if the ramps are unrolled. And what he's going to do is to take this picture now and try to place it in the scene so that he can see whether when the ramps are unrolled that they'll be okay.
Oh, so he's just testing.
This does not mean that the ramps have, he's just testing. He's practicing. And the wonders of modern computer science are that we can actually simulate all these things, and we don't have to just fire blind. We can actually simulate what it's going to look like.
They're actually unrolling. It looked as if they were unrolling a little bit there.
Right. No,
yep,
see,
there it is.
There they go. But that's just a computer simulation.
Right, correct.
And he can take the data that was sent down earlier and unroll those things over the real data from the Martian
surface.
surface.
That's what you're seeing right now.
That's what he's doing right now, John.
That's what he's showing right now, is he's now going to simulate what these ramps look like when they deploy. I don't know if you'll be able to see it very well from his screen.
It's fascinating, and we're getting a pretty good view because our crew out there at JPL is zooming in on the TV set or the computer monitor to let us see just what Brian is seeing. And,
now it looks very fuzzy to us because it's a 3D display, and we don't have 3D goggles, so it's going to look kind of funny and fuzzy. Also, he does these mosaics, these frames. He does not attempt to join them up seamlessly because then they would get distortion. So it's more important that they be accurately reflect where things are than they look pretty. They don't.
Periodically, he lifts his glasses and then he puts them back on. Why does he do that?
Well, that's kind of so he can get the perspective of where he is. It just helps him see the stereo better once he's seen what it looks like without it. Kind of like
there's his lawn darts that you were talking about. There's a whole bunch of lawn darts there.
That's right. He's got lawn darts.
Explain that to us again, Donna. Those lawn darts are for what?
Okay, all those lawn darts is Brian's really cute way of marking where things might happen on the surface. So once he puts in a lawn dart, it just gives the coordinates of that point on the surface. His Silicon Graphics workstation gives the coordinates of that point. And the lawn darts are just his way of being able to visualize where that point is exactly. And where they penetrate the apparent ground or the apparent plane of the ramp in this case is where the coordinates get read out. So there's Brian without his goggles.
Well, he's a nice looking guy without goggles, isn't he?
He is.
We are, by the way, to let everybody know, we're not getting any more pictures down from the surface of Mars right this minute. As pictures were coming in a few minutes ago, we recorded them on tape, and I think it's probably going to be possible for us to play back some of that videotape with the great pictures from Mars on it as soon as we can get it together here, and maybe we can look at them at greater length than we were able to when they were coming down live, because some of the great panoramas were only there for a second or two. Yeah.
By the way, what you're seeing here is scientists. Those are scientists. Remember I told you the scientists were all going to crowd around the TV screen and argue about which rock to go after?
Yep.
There they are.
That's what they're
doing.
It
right in front of you.
Well, there's one guy looking the other way. I think he may be a reporter.
No, there's no reporters up there.
Right. I had heard, Donna, there'd be about 100 scientists in this room in Building 230, not far, about 100 of them in
packed in like mackerel.
It is not a big room, John, by any stretch of the imagination.
And so we don't have any room for reporters, even if they're very thin. We don't have room for them. Not if they're John scientists.
No, that leaves me out for sure.
Yeah.
I see Wes Huntress from NASA, the system
Right, well, he
administrator.
counts because he used to be a scientist before he was an administrator, so they let him in.
There's another one of those first photos, but
Yeah.
we've seen those before. That's
Right.
the
Now,
wheel
oh,
again.
well, look down, though, here. See the circles with the
The circle in the middle, John.
the red circle, and
That
you see
tells
how
where
there's
it's
a little
pointing, right?
wedge? That tells where the camera's pointing. So you're getting a lot more information now than we were before. I'm not sure what the run on the right is, but okay, so when you see a picture and then you see the display down below, that shows where the camera is actually taking that picture. And that helps them with the mosaicing. It also helps Brian visualize. Oh,
All right, listen,
wow, that's beautiful.
that's fabulous. We're going to come back and look at more of these, Donna. We've got them on tape and got them ready to play back for you, and we'll be able to keep them up on the screen a little longer than they were when we got them in live. But we're going to take a break first and get our act together, ready to do that. Stay with CNN. We'll continue with our return to the Red Planet in just a moment. Our interplanetary picture show continues with John Zarella and Donna Shirley at the Jet Propulsion Laboratory in Pasadena. We're going to continue to show you the pictures, Donna. We'll slow them down. You and John talk in our final moments here, and we'll remind our viewers that 65 minutes from now, we'll be back with a NASA news briefing with the first color picture from Mars. If we get the color picture ahead of that, we'll come back earlier. And then 2 hours and 4 minutes from now, all of us will come back together for a half-hour special, showing you everything we've been able to gather so far today on this fabulous, mind-bending story. Donna, John.
We've been looking at these photos, John, and able to see the mountains in the distance, and now the close-ups, Donna, of the rocks.
Right, it looks like there's some sand drifted around the rocks, very much like what Vikings saw. These little dunes.
One looks lighter than the other, actually, doesn't it?
Right,
there?
it does. Now that could be because it is lighter. It could be because the camera's got a different sun angle. It could be because there's dust on one of them and not on the other. So we really won't know.
There's that hill in the far distance. It's
a mesa in the far distance, and that could be one of these streamlined islands. And it also looks like there's a kind of a hill over to the right.
Now it's not likely that Sojourner can get that far away, is it?
Well,
you don't know.
Not easily.
Not easily.
That mountain could be 10
a
miles
long
away.
ways away. That's right. That's right.
So we'll be very happy if Sojourner just gets to some of those absolutely luscious.
There's one that looks like the flat flat rock formation.
This may not be a flat rock. What it may be is a dike, what they call it. It's a little trail of sand. And that looks to me more like a trail of sand, but I'm not a scientist. Now, this thing in the foreground, this white thing, is definitely
Doesn't it appear, there's no question there is going to be a wealth of opportunities for the geologists to look at those.
Rocks. Now, there's a kind of a flat-looking rock, but see, those are perfect. Those are just the kind of rocks that Sojourner can get the spectrometer on, and without even having to travel very far. Now, this would be very difficult for Sojourner to go.
Look at that.
Donna and John, we're going to have to wrap this up for a little while.
Okay.
But we've got more pictures expected. We've got the big color picture 60 minutes from now. We'll come back and share that with you. And then 2 hours from now, all of us, including astronaut Story Musgrave, who joined the space program to walk on Mars and hasn't gotten a chance to do that yet, will be with us to offer his thoughts as we continue with our live coverage of this very remarkable journey to planet Mars. For Joey Chen and Leon Harris, I'm John Holloman. Thanks for being with us. It ain't over yet. More great pictures coming from Mars.
This is CNN International.
The following is CNN's coverage of a live event.
Hi, it's John Holloman at CNN Center. We're interrupting Larry King Live for live coverage from the Jet Propulsion Lab in Pasadena, California. We're about to see the first full-color panoramic picture of Mars in 20 years, maybe ever. And there's a slight problem with the Pathfinder lander. We're going to go live to John Zarella at the Jet Propulsion Lab to talk about that. John, hi.
Hi, John. Yeah, we're not going to give away the secret on that picture, but I hear it is just spectacular. But we do want to tell you, and Donna Shirley is here with me, and she can explain with our little model here very quickly exactly what the problem is.
Okay, the lander is lined up in this direction with this pedal pointing almost due west. There are airbags which are sticking up on either side of the pedal enough that they're concerned about being able to deploy the ramps. So the plan is they're going to tilt the pedal up about 45 degrees, retract the airbags some more, and then lower the pedal back down just to make sure there's no danger to deploying the ramps.
And at that point, then they would unfurl the ramps.
Right.
Is there a chance that we may not get Sojourner off tonight?
There is a chance that we may not, because they have to take more images to verify that everything's clear. It's possible we could. It's possible we don't.
We're quickly approaching Martian sunset,
right,
correct?
Martian sunset is, well, we lose the signal at about 10:20 tonight, p.m., our time. And but there's a lot to get done before then, and it takes a while to do these things, send the pictures back, and so on. So it's kind of iffy if we're going to get Sojourner off tonight.
Now, John, we don't want to steal all the thunder of the press conference, but we understand, again, as I said, that that color photo that we are about to see will give you a panoramic view of Mars that is something spectacular.
Spectacular. It is a gorgeous picture.
And we're going to go to the presser right now. We should get it quickly.
Okay. I want to see it.
The IMP camera, which is taking the pictures you're about to see, has a personality. And in the first slide, let me just show you for a second what it looks like. It has two eyes, spaced about twice the human eyes. The eyes even have eyelashes to keep out dust. And you can see it is smiling. It is happy to be traveling to Mars. In all the pictures from EMP, the eyes of the camera are our eyes, and in that sense, we're all on Mars. We're there together. You might say that the people of Earth are the soul of this robot. So for the first presentation of images, forget about the engineering and scientific aspects. They're very important, but open your imagination to the experience and the beauty of landing on Mars. Pretend that you are in the position of the camera. You've awakened in darkness after a rather bumpy landing. You slowly come to consciousness, and you remember you are no longer on the Earth. Your name is Imp. You've been hibernating in space for 7 months. The ride wasn't comfortable. Your forehead was pushed up against the solar panels. The rover was crammed against your left ear. The high-gain antenna mashed against your right ear. And that parachute canister straight down the spine. The scientists and engineers, both United States and German, that built you did promise that you would land in one of the most exotic places in the solar system, the flood delta of an ancient valley named Ares, a canyon so huge that it was capable of carrying 1,000 times the flow of the Amazon River. Dry for billions of years, the delta is now an ideal place to look for the diversity of rocks that contain the history of early Mars, and perhaps you will see some evidence in the pictures I'll show in a second of the dry landscape of the ancient water channels left from the last flood. For your first look, you're sitting close-legged on your pedals, coming out of your 7 months meditation, and you start to raise your head. And if I can have the first or the second slide, this is what you see. First, examine your trusty Sojourner rover. Healthy, ready to perform her mission. She's crouched down still, the way she was during the cruise, but will soon be released to stand at full height. Is this surrounding terrain safe for the rover? I'll let you form your own opinion. Are there clues here concerning the history of ancient Mars? Let's look together for the first time at the Martian landscape. Now, turn your head to the right and see the next slide, and we'll look to the other side of the pedal. Look in the distance. Those hills are not far away. It's too early for me to tell you how far, but they are fairly close. and look at that airbag bunched up on the right side of the rover pedal. And now I'm going to take you through a few close-ups within this landscape. And if I can have the next slide, we're looking towards the southwest, and the sun is over our left shoulder. You can see by the shadows. The sun's about 9:30 in the sky. And those boulders are the rocks that we will be investigating over the next few weeks. Those are the rocks that may hold the clues to the history of Mars. And in the next picture, we'll look at the rover and what it has to deal with. Now, as you notice, there are some dislocations in the wheels and so forth. This is due to parallax. As the camera turns its head, nearby objects move at a different rate than distant objects. And we have chosen to put the distant objects together, and we have let the dislocations be present in the rover. This is very hard to correct for, and we'll have to wait some time before we can get everything pieced together properly. If you remember, our camera takes frame-by-frame pictures like tiles. Let's look at another picture. There's the rocks and those distant hills. One hill has a little chunk out of it. I think that's on the border between two frames, and will be corrected. We have only had 1/2 an hour to put these pictures together, and there are about 120 pictures here. This is a remarkable feat, and the image processing lab here at JPL deserves full credit. They have never done a picture of this magnitude in such a quick time period. Okay, let's look at another picture. Now, ignore that little notch in the hill. That's an artifact, but maybe it's a mirage. But this is a fantastic landscape. You see sand there. You see a diversity of rocks. This is exciting for us, and this is what we'll be exploring. Now, let's look a little closer. Next picture. This is the APXS. You see that little can. Let me see if I can point it out. There. This is the APXS. This is the ramp that's still stowed and can be deployed. Well, I'm not sure that it will be. And the airbag that is certainly interfering with the deployment of the ramp. Now let's look close by at the soil. Next picture. Oh, I'm sorry. We have one extra in the distance. There's a very large rock in the mid-distance. Remember, this is a view seen from sitting on the surface. Tomorrow, or at the end of Sol 1, we will extend our mast, and we'll have the view of from the perspective of an adult standing on the lander. And I think this is the final picture next, a close-up view of the rock. And if you look carefully up, you can see some of the soil has been disturbed here, obviously from when the airbags are being retracted. And you can see a close-up view of a rock. And I refuse to speculate at this point what that rock is, but we are going to be studying that and hope to tell you soon what our scientific assessment is. So with those images, we are started on our mission. We're returning pictures as fast a rate as we can. Believe me, we want to see them as much as everyone else. And over the next few days, you will start to see some really more mature products coming out of this camera instead of this first quick look. You might ask if there were living organisms once here. You might ask many questions about these pictures, and these are questions we too will be asking. But remember, the imagination is very important to understanding this mission, and we will try and help stimulate your imaginations as we will stimulate our own and give you the sense of actually being on Mars. Today was a glorious day. The next few sols set the tone for the entire mission. And I will, with that, pass on to Mr. Dan Golden, our NASA administrator.
These pictures are breathtaking. It's a day I waited for a number of years. And there are all sorts of rational science that'll come out of it. And I'd like to just speak for a few moments about the emotion and the passion, because that really does exist. I had the opportunity to go over and speak to the science team and the operations team. And these folks are feeling really good about themselves, and by God, they should. They have done just a wonderful job. And while I was in the operations room, I got a little blotchy. I had to stop speaking because of the emotion I felt in the room. Yesterday, when I opened the press conference, I said I declared this mission a success before it actually lands, because I wanted the people who worked on this program to understand that the NASA administrators trust them, and I had to put my money where my mouth is to say, I support people when they take risk, and if they have a problem, I'll stand behind them, because I don't want to go back to the old ways of doing things. I want them to move in the future and have confidence that they'll be supported not by setting mediocre goals. However, I must say, this way is a lot better. And I just have wonderful feelings about the future, not just for the space program, but our country, given the incredible ingenuity and thoughtfulness and hard work and passion of these wonderful people. The 21st century is going to bring great things for our children. This is the second in a series of our new approach to spacecraft design. Watch out, world. Here comes NASA. Children of America, you're going to have a great future. Thank you very much. I'd like to turn it over to Dr. Huntress, who's the Associate Administrator for Space Science at NASA. He runs our space science enterprise, and it is through his leadership and dedication and teamwork and people selection, and he's a bulldog. He also doesn't give up. He got these programs started. So, Dr. Huntress, it's yours.
Thank you, sir. Boy, what a rush. Days like today is what the space program is all about. And I hope you all have really enjoyed the experience. The interest and excitement that's been demonstrated by everyone who's come here to this event demonstrates that this nation is still grounded in what makes it great, and that is a nation of pioneers and explorers, and you've had a chance to see them here. What better present can this agency give the nation on its birthday than this landing on Mars? It's just terrific. And Pathfinder was named Pathfinder because it was to demonstrate how to land on Mars at low cost. But something else was demonstrated here today that I want you all to really realize, and that is that Pathfinder is not the hardware. It's the people. And what a terrific team they are. They're a mixture of young, enthusiastic, excited, innovative, highly charged people with a few old scarred veterans to help them out. They were given a very challenging task, an exciting one, certainly, and told we didn't tell them how to do it, but to find their own way and not to fear. And they were individually given responsibility, they were given the resources and the authority to do what they had to do, and boy, did they ever perform. You've had a chance to see that for yourself here today. And the competence and dedication and confidence that these young folks have demonstrated, that's the way of doing things in the future, here at the laboratory and around this agency. But you've not seen the big hero in all of this, the project manager for Pathfinder, because he's let these young folks who did all of this take the spotlight. And he showed them his trust, and they came through for him. And his name is Tony Spear. He's not here, but I want you all to know that he's a real American hero. In 1993, I told Tony, here's your challenge. I'm going to give you the money, and I'm going to get out of the way. And he put his team together, he gave them the responsibility, and he got out of the way. He's the captain of the ship. His name is Tony Spear. Thank you, Tony. Thank you, Heiner, the Pathfinder team. Thank you very much.
John Zarella and Donna Shirley are watching this on television from a nearby location. Donna Shirley, what's going through your mind as you listen to what you're hearing right now?
Well, it's just, I agree with everything that Dan and Wes said. It's just absolutely magnificent. The pictures are just beyond our wildest dreams. The landscape is beautiful. it's perfect. It's absolutely perfect. The only thing we have to worry about now is what Brian is probably going to talk about, which is the condition of the airbags and the pedal and what they plan to do about that in order to get the rover off.
Maybe we should drop back in there and listen to what Brian has to say about that.
Right. I think that would be good. It'd be a good idea.
I'd like to do a couple of things first. As I said earlier, we landed in 1 pixel in that little ellipse, and we still don't know which one, but as you can see, it's a very happy one indeed. We are obviously not within any of those secondary craters that we showed you because we have a vast